Track next。你开会还带着相机？
这个
随时
兼职。
那你一会儿就负责帮我们拍照。超拍。哎。怎么每个人进来感觉表情都很迷茫？是不是进错屋了？
哦，我是不是带错口了呀？
是的，这是香港的。
带错口。
美国是跟我们是一样的，就2项的就可以。
我们带了3个。
哎呀，这大哥！
上次有那么多人吗？上次的单。
上次不是一开始就有，上次就是我们定的跟 Nova 讨论的那个环节来了一堆人，但这次这第一天就。哎，老杜，你联系得到三叔吗？跟我们差不多哈，联系他的方式。Nova 的人已经都过来了，这得把他叫过来，我靠。
换个人呀。
他要是不来了，我靠，就搞死他了。
只派给他一些等他回来。
今天是谁 host 的？你 host 的这个事情上。
对，我是 host 的，但是 topic 得有主讲人啊。这个我也不是所有的专家，我靠。大家先求让。你看项目力也过来了，这管用的已经都过来了。啊？哪个什么？对，有点变性的trans， 应该是。他长得太好看吧？旁边那个还行，换，这都录上。哦，我用他的，哎，他真。
然后跟大家去说一下，转组这个。
啊，他也来，修文也来。不是，那个谁，他是那个肖文阿拉斯，他也是管说话管用的。
那我的。
对。要不要这么严肃？哎，正好熟悉那个。
不要让他 host 他英语不行。他可以说，他可以那什么，但是。
我得。
所以说你 host 比较这个啥，然后正好讲。
我 host 我也不知道讲什么，主 主要是。
主要是 OIC 才真的熟的时候。
Hello， 哎 ，Howard。
哎，
让利
杨丽说 host 了。
啊，什么东西啊？我操，我这么大老远 host 啊？
哎，你今天是请假了吗？
对啊，我请假了。
要不你来 host 算了。桑德尔没来，桑德尔到现在都来。Nova 那边几乎所有人都来了。
我靠
，Nova 所有的 core 都来。
我 host， 我现在关键没啥准备，我靠。不是，主要是不是要谈一下跟 Nova 那个？我操，那谁不在？
我就说，对啊，我就说 Nova 他们如果上午过来的话，上午就讨论。
不是那 Thunder 呢 ？Thunder 人去哪儿了？
我不知道啊，谁都找不着。
他来了吗？
本来是应该是来了吧？
我记得他说他来啊。
我在群里还艾特他了，他也。
直接给他把视频给我给他打个电话。
跟 Nova 相关的几个议题，我们不行了，先提前抽出来讲。
对啊，但是要 Thunder 过来那什么呀？他
不是他写的。
对，那个 Etherpad 好像也是他，不知道是不是他传了一个。
哦，对。
他要说这个介绍进展啊什么的，怎么之前讨论的怎么着了？
对。
他应该很快。
我单独跟他发消息问我。
哎，是别打窝去。
the time was bigger than that. Yeah. Like when we went to Dublin, I used extra space. Yeah. Almost 250 miles. Instead way down and make because that's just there is no technology now, it's just located only for
他干嘛呢？
住在哪？
我还以为找老杜，你联系不到三个吗？你刚才是去找人了还是去上厕所了？哎呦我去！那咋着啊？
我看现在有哪些 topic 是能讲的？
也可以按照原来讲，但感觉大家都过来了。
我们先把 retrospect 讲了呗，这个我觉得第一个先这么走也没啥问题。
行吧。Okay, morning everyone. Welcome to the Cyborg's PTG meeting. I put almost all the information on the Etherpad. We have a Zoom call link because we have colleagues that cannot attend in person. They're calling via the bridge, the Zoom bridge. So please also feel free to join the Zoom meeting, and when you speak, you can unmute yourself. We are recording like the whole session. And please add yourself at the attendance so that we know who comes. And shall we introduce ourselves a little bit? Okay, starting from me, I'm Howard. I was the PTL from the Queen and Rocky release, and I'm from Huawei, and that's about it.
everyone of you. And I'm now in our OpenStack Foundation. I'm the China Community Manager, supporting China community around OpenStack and other foundation focused projects.
I'm Matt. I work on Nova. I'm mostly just like.
I'm Steven, exact same story as Matt.
I just wanted to be honest that I would pretend that they will work, and no, to be honest, I'm Sylvain. I would like to learn more about Cyborg and particular people in interactions.
Nice.
And I'm Ajit, and basically where I'm from, I'm interested in like Cyborg. They're a free node contributor. I'm interested in getting device pass-through happening, whether it's with Cyborg or not with Cyborg, but preferably with blockchain, but also GPU.
I'm Brandon. I work for Linaro. I'm tech lead things like CCIX, networking in Linaro. I don't actually work on Stack at the moment.
Interesting. CCIX, right?
Yeah.
That's very interesting.
I'm Dan Smith. I work on Nova.
Okay, brave.
I'm so many.
I'm Jia. I'm from Lenovo. I'm come to see the Cyborg since this year.
Okay, I'm Sumit. I work for Suze, and for Cyborg, I just came looking for GPUs integration, but that was so. It looks like it's going to be so involved.
I'm Mr. Yamada, working for Intel. I'm working on Linux.
Hi, this is Mishman. I work for AT&T on the high performance Linux, and I'm interested in this networking performance.
I'm Takashi. I work for PTG Corporation. I am more content.
I'm Krista, so I'm a contributor, working in academic markets.
I'm Ming Yang from Intel, and I'm interested in Cyborg through which company integrate Intel microscope design activity device.
Hi, I'm Dr. Du from Intel, and I'm working on the FPGA support on Cyborg.
I'm Zheng Hao, and I'm from China, working for Lenovo, and I'm a co-reviewer of Cyborg.
I'm Coco, and my interest is network acceleration and PTG technology, and I work. I'm in Cyborg project for mainly half a year.
Alex.
I'm Alex. I'm working in Nova.
Okay, thank you, everyone. Since I see most of the Nova folks are here, but Sander is not here. So will you guys please do like stick around in the afternoon? If okay.
Where's Sundar if he's not here?
No,
They don't know.
should be here, but he's not here in the morning. Don't know why. We are calling him like crazy. But anyways, so I think then we just stick to the original schedule agenda. Okay. Oh, and we have Lilio. Can you introduce yourself?
Okay, yeah, it's Lee here. I'm the new PDL for Cyborg project. I couldn't attend the PTG this time, but yeah, I'll stick around in the Zoom. Yeah, I work for Huawei in Canada, and I'm a hardware guy, like originally, but I'm also interested in the cloud technology, enable all these hardwares in the cloud for the users. Yeah, that's it for me.
Lily prepared a very interesting presentation on the domain-specific architecture support. So if we could have time this morning, I think he can present. Okay, so let's just go through the agenda. First of all, the Rocky retrospective. So I think most of the bad ones are we can reshuffle the agenda. Yeah.
Hi guys.
Sander is here. Are you?
We are waiting for you.
Will be comfortable to start the NOAA discussion because NOAA folks are here.
Sure, this is scheduled for 2 in the afternoon.
So yeah. Yeah, I think we can just shuffle.
Waiting because there's a couple of other people who are probably expected to be here at that point. We're just
Oh really?
Yeah. So we're
okay.
Just continue as if we're not here.
Okay, no problem. So continuing the retrospective, I think most of the bad things about is about we didn't get many of the, especially on the driver side, the desired patches in the official release, and the development process is still a little bit chaotic. I think we can continue to improve during the Stein release cycle. So anyone else on the what do you feel was good or not good during the Rocky release? Other than the things I just mentioned.
I think a good thing is we did a lot of good discussions, especially on the enabling the drivers and the modelings. A lot of good things. Only thing is we still have too much discussions on some of the specs and still haven't settled down yet. I hope we can get those things going soon.
Yeah, so discussion needs to converge faster.
We didn't have a lot of specs, but approved with a smaller process. We wanted to understand how to collaborate across different projects. So this is where figure out how we can activate and
having to be something that I don't know if he's going to so that they can do some rather than having one of the other projects will do
that's not how this connect was. I thought I couldn't Cyborg and invite all the world experts.
I think the NOVA interaction should be a NOVA spec. That's generally how we do it with Ironic. They'll implement a feature, Ironic spec, whatever, but the interaction part, the things whatever, and view manager happens in the NOVA spec. And that way you get visibility. Do that in the workflow, all the other things will go.
I am writing more specs, more specs. If you say other specs, you think with other specs as well. And sometimes those things just one.
It just needs to be like more and more action.
Yeah.
It doesn't need to define everything else. You guys might have in your spec for like so it's for the initial no interaction at all. So the other thing that I mentioned is the problem getting specs closed extends possibly from having too much implementation detail in specs. And so the way the workflow is set up in Garrett is it's good for implementation detail and for the low budget time. You work that out using the code. You can throw code up there and it's no non-starter. You can throw it away. But trying to put all that detail in, you'll just never close it. So I think keeping the specs higher level.
By the
Going back on PSP, it is good to have one wiki page, one specific page, so everybody knows who is doing what. Right? So your task breakdown saying this being done with this person, not this company.
And as Cyborg is so small, that would probably be okay. And rows that doesn't. So I can try to that number, I just don't want. But for Cyborg, it probably is okay because it's going to be a second that's very much what I implementing PTG driver, implementing PTG driver, and ignore independently. But the way I think doesn't scale as well.
That said, even though we have a weekly pad with priorities and people's needs.
Yes.
Yeah.
Is there some sense of who is doing what?
Yeah.
Duplicating things or dropping them off?
Yeah. So again, if there is not too much trouble, please sign into the Zoom link because video cannot hear you guys clearly.
Sorry, guys.
Okay, I did another one. Documentation really sucks, so that'll be another. Yeah, I talked to the GTE team. I think they are still on board. So, yeah. Anything else? Okay, so for I'm not super familiar. How do we do like the project level governance? How do one does it? Like how many +2 you need to land a patch and stuff like that? Do you have like
usually at least 2 + 2s to land a patch? There's a few different ways that it's been done differently. Nova for spec, you have 2 + 2s usually with them to come from different companies as well.
Yeah.
On implementation, the different companies being a little less strict, but it's still
What actually does says the project team guide. It tells you can have your own policy.
Yeah, it's a colon divided policies in Mava. So it's actually partially. They do not allow you to use a -2 on a spec, so no code but they require on a spec they actually require more than the course.
Yes.
So they come to a column that way. But for the patches, they just go with the standard 2 + 2s and then +1.
So where is this documentation like?
You mean the project team guide?
The point is that it says you can make your own policy.
Yeah, that's what the question.
Yeah, no, like where should we document
the
it?
governance people will have the different microphones there.
You're asking where should you document it for your project?
Yeah, for Cyborg.
So we have it in the node tree.
Oh, contributor docs. Cool. Okay.
But my problem is we don't, yeah.
Okay. I think we need.
Considering the volume of work and the size of the team, you could do a quorum thing, or you could do a 2 + 2 thing, you don't help the work. As the project gets larger, asking for quorums probably harder.
The reason I actually worked with Gold team was they reserve specs for things that are controversial or very big, and they try to do as much through this code review as possible. So that's why they get rid of the scaling issue with specs with effect like that. Relatively low.
Okay. So I think we might need some sort of like documentation to describe the project level governance. So for example, to land the patch, I think the normal way is to have 2+2s from cores from different companies, right?
Yeah, and usually not the
and not the submitter of the.
Can I just make a point? I actually wanted to look at more documentation, but when I look at the documentation, those are pretty, I would say, small. So if you are saying that you should consider documentation and say the contributor policy, I get you more than that, and to have all the policies that you have as all your like discussions that you have in team. All the stuff that you have to that you want to edit. I did like for example how to define and all the stuff to be done also on the documentation part, not only on the reviewing policy and that stuff. Because I'm just at the moment looking at the Cyborg documentation and that's really small. So in particular for the contributing side, it's just telling me how to build video and that's basically
well, that's a specific screen case if they come to the code trust template. So there's a few changes, but not significant.
还没完事了，你有体温表吗？我找一下。哦。
Okay.
This is completely on topic, but from a governance perspective. One more time.
So I'll just talk real loud and hope that you're keeping it up. I was going to say, splitting your specs out, I know there exists a Cyborg specs repository.
Yeah.
I think you should.
Yeah.
So you have a patch up to do all of it.
Yes. Yes, we're starting that. Yeah.
Which was warning, yeah. Well, yeah.
Okay. Any other suggestions on the like governance? What you like or what you don't like? The project to do. Approval. Well, anyways, I think it could. So just submit the document for the contributor doc, and we can review it. Okay, moving on the database evolution. Who's the owner of the subject? Coco? This is about the OVO, right?
Yes, OVO.
Okay, take it away.
For the DB model change.
Can you provide the review, the link on the Etherpad so that everyone knows the reference?
So as for now, the DB is not specific to the PCI device, and we think we should move forward like there are many platform or many other devices we should support. So we need to expand our DB model. So,
So can you provide a review of
Yeah.
You only have one migration into the code, and when I see the migration, and then just
Are you asking about how to transition the schema of your database from one thing to another?
Yes, I think we should add some field to identify the platform or something that we on Cyborg need to store. If like there are many different like PCI device or MDF device. So I think I don't know whether we should change our DB model right now. So maybe just for this open discussion.
Are you generating the DB tables from Apple 3? Or you just go out and create it by hand?
So
they're using Clover.
Yeah.
Is context what you said. Initially, look at Cyborg was not TFs and BFs. Most of it is database reflects how many different ways using PFs and actually using BFs and all that stuff. What you're saying is you need to download beyond and put non-PCI stuff. Eric has been a lot of feedback about how a VM consider non-PCI BFs.
The current schema has to evolve.
Yes.
And you've got to move the data and translate the data, right?
But so that was my first question. So as far as sorry, my second question was about the object modeling that you make. Because you have, I see a lot about also objects. And what's the current status with that? Because if you want to model, if you have all of your yes.
I think the question I think is how you're going to evolve not just the schema, but get things translated into the new format.
Yes.
So that anything in the database now will be in the database in a new format with fields changed for PCI type specifiers and things like that.
So right now Cyborg is in the early phase. So I don't think there are any guarantees for backwards compatibility.
Right. But the technique got to be one. Yeah, you really tag it. So once you tag V1, you really should be supporting a upgrade on.
Absolutely. So you shouldn't have, in my opinion, you shouldn't try to fit yourself into this like experimental model where you're like, well, we don't really know what we're doing yet, so we're just gonna blow things all out, and like, that table didn't work out, let's just delete it, and whatever, because that means that everybody that is playing with the Cyborg right now, waiting for it to get to a maturity point, basically from scratch every single time, because there's not a solid path, right? So I think that given what you guys have advertised for yourselves in terms of like, we want people to be trying at this point, I think you should try to get into the pattern of doing proper upgrades of your database and any RPC APIs that you have. It's so much harder later to be like, okay, everybody, okay, we're going to start doing it for real now. It's really difficult.
Going forward, definitely I agree with you. I think in Rocky, I'm not sure if it put enough thought into upgrades and everything. You guys want to speak up. We just kind of finding a way out, waiting for next episodes to and all that stuff. So I think going forward, from saying once we get clarity on how things are going to work out, we can lock things down and make it be one.
So
no, but the order is tagged.
Yeah. So now, the problem I see with that is that if you want to modify your model now, without waiting to have the objects modeling to be in place, then it's a recipe for failure, because then I guess in my mind, if you want to modify from a touch your model because you feel your model is a bit constrained and then you want to evaluate it, then I guess probably in terms of priority, I would consider having the object model in place with virtual machine objects would be like the first step to do so, and then you will modify your model, because when I'm just looking at the review, that's at the change that someone said about the object versioning for Cyborg objects, I think it's like the main thing to do first before evolving anything. Because if you want to modify something, then you will get a framework for modifying your model. You will like be thinking about how you persist it, how you modify it over the wire or not. That's really the early steps.
And just to be clear, you guys have released 1.0. It's done. So Cyborg 1.0 is out there. So that, yeah, I mean, it's like on the releases page.
It's on my
It's done. So going forward from here is what we're trying to say. You really should act like a 1.0 project.
Well, it might be also they're released in Queens. There's important Queens as well.
Yeah,
so
but
because we put out there, what would we want to do?
Well, you can call it minor release, so you can grab the major. And if you're going to make a breaking change, then yes, grab the major version goes to
Cyborg wasn't released in Queens though.
Yeah, wasn't part of the cycle with Milestone. Yeah.
Right. And the Rocky release was 1.0.0.
Yeah, that's the first. Yeah.
So I had gone through and looked at your objects, as well as the fact that there's a conductor and some other kind of buzzwords that people have in OpenStack projects these days. But I hadn't really quite grokked it. But are you guys trying to do like no database access from the compute node kind of model, like Nova does, or?
That is the intention.
Yeah, yeah.
It would be nice if you guys do that, so that you kind of keep the sanctity of the compute node not needing to talk to any of the database servers.
Yes.
That would be cool. Okay.
Yes.
But the API, I assume you want the API just to hit the database all the time, right? For performance reasons.
Database all the time?
Yeah, not go over RPC to pull everything.
Oh, okay.
Oh, it could go by the conductor, but yeah.
It can, but we don't for that reason specifically. I'm just asking what they want. But
so the agent has to speak to the conductor to get access to the DB.
Yeah. Agent is good. That should happen, I think, for the agent to keep the compute node from talking directly to the database.
Yeah.
I'm talking about the external API.
Yeah.
Yes.
Usually, the Nova will let the external API talk directly to the database and not have to go through conductor to do all those things for performance reasons.
Yes, also because the actual database endpoint is usually far out of control as well. So it's not on the compute node, it's
on
you don't have to put credentials out.
Uncontrolled type deployments, yes. But I mean, on big deployments, you got a database.
Oh, yeah.
But that means the translation across versions will be duplicated in the conductor and in the API.
Well, not if you do it right, that's the point.
Yeah, so it'll be able to see translations between object versions internally if you version them correctly as you're making the modifications.
Right, so this gets back, I think, to what she was asking about how to do, how to support changing your schema without breaking everything on above, right? So, and the reason I was asking is that if you don't want to do any of this compute node database isolation, then OVO might not be worth the overhead for you, but if you do, it will do all kinds of stuff for you and make that easier. Okay. But, so generally the thing, like if you take this PCI example, you would add a migration to change the schema to add a field or whatever other thing that you need. And in Nova, we try not to modify the data in those migrations because if you do, you kind of, you put a lock on the whole deployment. And you require everything to be down basically while you move all of that stuff. Yeah. And so in Nova, we add schema additively. So we would add a new field for device type or bus type or whatever you want to call it. And it would be like none by default. And then in your objects, when you load stuff from the database, you would see that field is empty. And you would say, well, before that schema change, anything that was in the database had to be a PCI device, so I'm going to default that value to PCI or something like that. But new devices that get created would have potentially a different value in that field. But if you hide all of that translation of the data in the object when you load it, then you get this kind of ability to roll forward and your upgrade a little bit easier without having to like shut everything down. And I assume that Cyborg is going to have like millions of rows because you're going to have like thousands or tens of thousands of compute nodes, each with 100, devices per or something. So it would be good to not try to upgrade your data in lockstep like that. Just like we have hundreds of thousands.
Well, in that particular case as well, you have to make sure that when you're doing this upgrade, that you can kind of do a rolling deployment. So you may have some nodes that still expecting your database schema to be present, so you want to maintain the sanity of that table so you can meet the old fields.
That's why if you do all of that in an object and then you implement your conductor properly, the nodes don't really care about the database schema, they care about the object schema, and you get to translate between version 1.2 of your schema and 1.1 of your schema in the object.
So perhaps we state my concern up front. We are still in the formative stage. We used to get the basics done. It's not in there yet. So if you start focusing on all these database conversion stuff, I just concerned with
Yes, I understand that it's
I
the inertia
understand
thing.
I understand the point of going forward and making backwards compatibility. If you efforts and all of this stuff, completely agree. But should we be doing this in time?
Yes.
I think get the basics.
I think you should have been doing it.
Yeah.
Since you're releasing Rocky, in time you need to keep
Right.
that thing.
So Rocky
Not
doesn't.
this time. Nobody's really using this in Rocky yet.
That's you cannot assess that, right? You cannot assess that since you released the 1.0. Now you're part of the game, and you cannot just assess that nobody will use your own project. I mean that's pretty unfair.
And here's the thing, like when you get, I'm sorry, I'm interrupting you. You're this right. But when you get to T, and you're like, Cyborg is good to go for T. If you have no stability history at all, people are like, well, I'll wait for you until I see that you guys can actually do this. Before I'm going to put it in my distro or put it in my product or whatever. Being a responsible 1.0 project and doing this upgrade thing, even before people are using it in production, is an important point of maturity, I think.
That's the only problem. Consider people just making your project as investing, like integrations as you see. And then they say, oh cool, there is a new release. So that's a 1.1. I'm just going to install it and then it breaks. What do you consider as an experience? I mean, if people want to play with your stuff, just to evaluate it and to see if it's worth packaging it, for example, and then during one minor release you break it, then you make it a terrible user experience.
And it's just really hard to get everybody, like I was saying, like, okay, settle down now, we're going to be real, and like counteract all of this inertia where you've just been throwing stuff in RPC interfaces and database schemas and everything, for 2 years because we're experimental right now. It's really hard to turn that battleship back around. And so building all of that infrastructure from the beginning is.
And with the particular aspect that you're running an agent on computer side. I mean, not all the OpenStack projects have this kind of scalability, sorry, but you guys have your own agent on each of the computers. So you can assume that one day you will be running on a large cloud like, I don't know, for example, CERN. And in that case, if you defer this kind of interaction in between your agent and all the other stuff, I mean, you will have more problems in the future because of that. So probably, I don't want. I got the fact that you are very limited in terms of resources. That I strongly understand. But what I'm just trying to explain to you is that given your release in Rocky, probably Stein is like the perfect moment, and I know it's terrible in terms of future delivery. But sometimes you have to make the effort, even if that's not now, that's later. So choose your battle. Choose your battle.
We're trying to offer, we're beating you over the head with past experience, right? Because other projects have not done any of the versioning type stuff ahead of time and tried to turn. It's tough. That's okay.
Including Nova.
Including what?
Including Nova.
Yeah. So both the first one.
Yeah.
I have scars.
How about the internal RPC within Cyborg itself is not supposed to be locked up?
So that's a point I think that we need to discuss on the OSACC spec as well, right? Because at one point, well, it depends on how you decide to have the interaction between OSACC and Cyborg work. The spec was implying that would happen over the RPC bus, which on hindsight, I think is actually a mistake unless we put the object definitions into OSACC.
I changed the workflow considerably in the latest spec.
Yeah, so if you're using the OSACC against the REST API,
yes,
then you have a little bit more flexibility. OSACC is going to be executing from within the Nova Compute agent. If that's operating over the RPC bus, we need to move all of the RPC objects into OSACC so we can then review them for compatibility, because Nova is going to need to support cross-version upgrades and
Well, and also you might not have we would have to end up with Nova having credentials to the Cyborg part of the RPC bus, which is not really awesome.
Well, the agent itself doesn't have a subsection of content nodes like most of it has. So but if you're right,
Things are loaded in Nova, yeah. So it would be much better to have the bit of Cyborg that runs as a library inside of Nova speak to Cyborg via the REST API, ideally.
yes. OSACC will talk to Cyborg in the statement. So let's take
So that means that the actual RPC version question comes down to, do you want to allow a rolling upgrade of Cyborg? So you can, or you would say, I'm going to shut down all of Cyborg, upgrade all of them, and bring it back up. Okay, because so really, you might want to rolling upgrade, it's more tech debt, that means you need to be very strict about the RPC version.
But there's the OSACC part, which can run, who's going to run basically in Nova process space, right? But there's also an agent that they have, which So what he's saying is, in a distro environment where nodes get updated a lot, like monolithically, if you can't have older code running in your compute nodes than is running in your conductor and in your API, then you're going to be a problem for blocking upgrades of other stuff, Neutron and Nova, that can handle this back level thing.
Okay. So essentially it's a requirement. It's
No, I mean,
version RPC should be a requirement.
Yeah, but that's the point. I mean, to be clear, not all. That's what I was just saying like 5 minutes ago. Not all the projects pretend to install something on the compute services. But you guys have the assumption to have some code to be run on, for example, 100,000 nodes. So consider a second if you don't do. I mean that's just priority matters. That's really your choices. But what I'm just trying to explain to you is that you are dedicated to serve large clouds. You are dedicated to be scaling out, and given because of your architecture, you have something to be run on compute nodes. For operators' perspective, it's very important for them to have the ability to manage it, not on a pure lockdown, because for large clouds, this is. I mean, if you don't do that, if you don't, I don't want to talk about risks, but if you don't do that and release, let's say, Stein with a good stability, but not rolling upgrades, then not having rolling upgrades, not having rolling upgrades support could be a pain for operators because it will prevent them to be using Cyborg, even if that's stable.
I think the important part is that if you are co-locating stuff with Nova and Neutron and these other projects that scale and upgrade on compute nodes, you kind of need to match the ability there so that you don't create a blocker for deployers and operating system packagers or whatever that need to upgrade those things.
So just to report on that, OSACC is giving us some level of interaction, which means you don't necessarily need to upgrade Cyborg every time you upgrade Nova Neutron file. We don't change that, but you're still going to want to have the rolling upgrade capability if you go with the case of I'm accessing the DB via the RPC bus. If you make that decision to now for OVO, you really want to have the rolling upgrade capability.
If it goes in, it goes straight from native to DB. Maybe you don't need it. Not upgrading Cyborg when you are upgrading other things is really only going to be doable if everything is completely containerized, which not everybody does. Otherwise, you've got the dependency problem on the compute node, and it's just a whole mess.
Well, so but Nova will depend on Cyborg, right? It will be an optional thing.
No, but Nova will depend on some lower constraint version of Oslo, what you call it, and then break. That's always the problem.
Yeah.
So general question, right? If you don't have an agent in each compute node, it probably simplifies upgrade.
Sure. You're trying to wiggle out by not putting some kind of compute node now?
I'm just thinking, I'm not saying anything.
Just to
But
answer our question, yes. Yes, of course.
Sure. Also,
but-
let's say where.
But flip side is, let this completely mind. The flip side is that if you do have agents, allows you to spread the load. Then you're not able to connect it. Helps you scale.
I'm not really sure how you would do what you need to do without an agent on compute node.
So
I don't know.
you may not be able to put an agent on compute node in all cases. So in the PowerVM case, I'm not sure if you will be. In the cluster hypervisor cases like VM or vSphere, you're not going to be able to run an agent for that node. You're going to need to use the hypervisor's API to your program. And do this stuff. So,
Well, where the agent can do that.
yes, the agent may not be actually executing on the hypervisor, the physical.
But that
server.
doesn't matter for those hypervisors. For those hypervisors, that's how you access that stuff anyway. So I don't think that's
Certainly for power.
Okay.
Yeah. I mean, I can't speak for anything else, but like VMware.
Yeah, but the point is, you don't need to be running on a hypervisor node if you're on a hypervisor that where running on it doesn't matter. So
yeah.
So now upgrade the scaling stuff. How is it resolved in other cases? What are the trade-offs you consider?
well, versioning for upgrades, right? Versioning the RPC bus, versioning the schema of the data that you're speaking over the RPC bus, right? We generally in Nova only support the current version and one back. So you can't be running like the Juno compute node with a Rocky API. You can only straddle one version gap.
How does it fast forward upgrades? You could jump from Juno to Rocky.
Fast forward upgrades you can't be running. Fast forward upgrades, you're opting for fewer releases, and the trade-off is you don't get to do it while you're running. You have to turn the cloud off and do fast forward upgrade as an offline operation.
But then when you bring up the controller, the newer release, the compute node is still sitting over the release.
No, you shut down the agent on
The entire cloud fast forward upgrades as a whole.
Yeah. So there's a control concept. There's fast forward upgrade and there's rolling upgrade. Rolling upgrade, we keep everything alive and we shut down, or we upgrade the individual package fast forward, we pause the entire cloud, and we don't treat the releases ahead. Going through all of the schema migrations and any live object updates that we need on the way, we just jump from release to.
So just to give you a taste of the meaning of running a release. So you have a Rocky release, right? So say I'm an operator, I want to package and I want to deploy on a Rocky cloud, I want to deploy the Cyborg API, Cyborg conductor, and I want to deploy the Cyborg agent. So I'm running Rocky compute nodes. If I want to apply it, I can apply it Nova, but I will necessarily have to stop all the compute nodes. I mean, at least all the agents, all the Cyborg agents, on the same time than the Cyborg API when I'm just trying to apply to Shrine.
That's if you're not doing rolling upgrade.
Yeah, I'm just trying to explain the impact. Because by some extent, you will probably have to consider that. And what I'm just trying to explain is that what means running a black to operators is that they have the ability to just do a short minimal downtime on the control side, just to apply from one release to another, but they still have the compute nodes to be running the previous release. Okay? But if you do that, and then you don't have Cyborg having the rolling applies capability, you won't be able to restart the Cyborg API until all your Cyborg agents are fully upgraded.
Right. Yes.
Which is kind of a problem with operators, because some people are, for example, running Puppet, Ansible, or whatever they have for managing the upgrades, and so they probably have to descope Cyborg from the pure web process in that case. just to manage Cyborg by itself. And when you have a large cloud, then the Cyborg PTG will be down for a huge number of time.
Which might mean the Nova can't work.
Yeah, that's what I was about to say. That could be a problem for us.
Which would be one of the markets that we would fail to boost or modify any existing instance. No.
Okay,
but yeah,
Well, it depends on how integral this is to your cloud.
yeah.
Yeah. In that case, I mean, that's actually also a good point for the Nova interaction spec. I mean, if you I'm not saying don't do that or do that. I'm just trying to explain that in the Nova interaction, you will surely ask about the Nova model that you have yet. Because if you don't have a Nova story, then that's a big problem for us, because then we need to make sure that we can opt out your own API and make sure that we can actually boost servers, we can actually boost instances without having your dependency. That's a big responsibility for us as well.
Can I just say one thing? We started this particular conversation talking about DB also, and maybe go back to that, and we can cover those again in the Nova piece later. Or whatever.
Sure, and didn't want it too much.
So what are the summaries you would like to seek?
So we set the DB model now as the initial version, or just add the and do the changes as the higher version, or we just we change the DB and then set the initial version of the DB model.
I would say whatever you release as the Rocky version, you should assume that's set in stone and you won't modify from there.
Which means add a new Alembic migration to add the thing that you want to do, and then make sure that all the existing code can handle that field not being set, because it might not be set if someone has upgraded from Rocky. And then in a separate release, add the code to the objects to load that data out of the database if it's there gracefully. And then in a separate patch, whatever you need for your API and your agent and that kind of stuff.
So I'm a bit confused because I'm able to see some objects from the side. I mean, if I understand, you have all the objects that you manage through the API are in their own. I don't think those are version objects, but I mean, I know what looks like to me they are, but for the agents, I'm able to see an open change. Currently on review, I shouldn't, by the way. About the versioning of about the objects for the driver side. So I don't know if, I mean, back to your question about what should I change and how can I make the open smooth. Are you still guys having some patches up for like the, I mean, are we all clear about what you currently have, what we need, and what needs to be deployed first? Because that's a bit unclear to me whether you have all the version objects or if you need more for blending what you want.
So right now, the version objects you have are still PCI device specific. So you're going to need to add in new version objects. And then you have a choice of how you model this in the database. So you could have, if you've only a limited set of device types, but many vendor implementations of that, you can have a database table per type and completely disaggregate those. You can denormalize the database and have this type field inside it. That will impact your performance because, depending on what you're doing, you can get more optimized queries if you set the tables, but it actually does make it a little bit harder if you've got a device that could be represented as one of like two types. That basically makes that impossible because you don't want to have them in two different database tables. So it depends on what your constraints are. The one thing that advice not doing, which is what we ended up doing in Nova in the past, was never stored like JSON block in the database. And we told this stuff. That is a block because we thought we were going to version that thing and monetize over time. So we said we're not going to have separate database for this. We have added fields of maybe twice in like 4 years. So you're better off to think about your database schema up front and actually create those tables up front and keep that than actually go in.
Well, they already have a blob on the attribute list.
Yeah, so that's simple to convert into just a two-column table that has
Yeah.
the attributes.
And then the other question I have is like those attributes, right, are all not needed for the scheduling. So they don't have any feature capability. So they need to segregate the attributes to represent the feature capability of the PTG versus the ones, the attributes they need for the user to,
See, we store blobs in the database that we specifically aren't going to query by.
Yes.
Which is, I think, is totally fine. But complex structures that are going to evolve obviously are a huge problem. And sometimes we store version objects of blobs in the database, which gives us the ability to do the compatibility load out.
It does, but it also means that for things like numerology one in particular, we can't use any SQL queries to say, I've got enough cores or enough RAM and I didn't know in the database. We just pull it back into Python, we do the version compatibility stuff, then we do this in Python, and that's slow. So if you have something like that, you can come to evolve. There are pros and cons, but if you ever need to index into that blob and make some query on to decide a schedule, let's say, pull this out of the separate table. Don't do it into Python. But if it's something you're not going to query into, and it's just some arbitrary like vendor specific stuff you need to pass to back into,
Or just don't do that part, but we have no blobs for like user metadata that we won't query because we don't own it. Like it's a thing that we store for you, but we don't look at it. So that's a legit reason.
Because as a service provider, we may have FPGA in one region, and some of them are configured with this capability versus.
If it's something you're going to have to query on, then it should be.
So that's why I'm saying if we take care of that now, it will be easier to have a mix later.
Yeah.
So one of the things is, if you ever want to go from a blob to a non-blob, that needs an online upgrade, because you can't do that with SQL queries to actually do migration. You need to load it in while the process is running and do it, which has again upgrade implications. So it means I need to bring up the service in that version. So if I'm doing a fast forward upgrade, it means I need to at least start that agent to pull it in and run it. So unless I write specific code to do that, like the DB manage stuff we have in the manage.
Yeah, you don't store the agent for that though.
You don't, but you need to have something that will load the data back in and then pop it on.
We don't do any data transformation at all in our migrations. Yeah. So it doesn't matter whether you're going from a blob to a non-blob or anything. We do it all in Python so that we can control when it happens.
There are other some statement I read is like Cyborg database is the source of truth. So, but if the scheduler is making the decision on the Nova, and what is the sync mechanism?
There's two parts to that question. One is the Cyborg database has a source of what devices are available, like resource tracking and Nova. But then there's also the placement queue where we just have the quantities. We don't know which specific devices are available, we just know you've got 4 of that type of device on that host. So scheduler is working on the placement model, which Cyborg is only populated. But the actual understanding that device 1 and 3 is free, that's the Cyborg thing that nobody doesn't care about or need to know about. And the scheduler doesn't need to know about either. There may be some aspects like the Newton affinity of those that we'll care about, but again, that comes down to how we model this in placement, and we should be able to extract that out without leaking it across the API boundary.
I mean, how you guys manage your object model is totally up to you. What we need to discuss is about how you model the object model to the placement system, because then you have this kind of relationship in between the model and the placement model. And that's partly what the spec with placement should be discussing. But apart from that, how you manage that, how you persist that, up to you.
To start with what they said, this is source of truth. It means that all of the rest are discovered by Cyborg and source database. They represent that and Nova as the source providers, the source classes, traits, and so on. However, if there is one unhealthy, or if I administrators mark something as job marketing used, they'll still sit in Cyborg database but not reflect on Nova.
No. But you will send it back down in the Cyborg database and put the reason in the Cyborg database. In placements, you would recognize the capacity,
Yes.
otherwise you would break it.
That's correct. What I'm saying is it would not show up in NOAA's old dress unhealthy, why would you need to sitting in placement database?
Right.
So now the source provider.
But if you have an administrative API that allows us to change at runtime, you will need to go back into placement and remove that resource provider or change the inventory value. And if something is already allocated from that, you may actually want to block on the API, on the Cyborg API, to prevent the operation from doing that, to take a little broken out resource value.
I think that's the same thing, because I am saying in that case, it should not show up in placement, it's zooming in placement.
But what I'm saying is, if it's already in placement, and in the API you set this flag that says this is no longer schedulable, you need to now go fix placement, and you may not want to allow that flag to be set if something from that inventory has already been used for an existing VM.
I don't know why that would be. The admin is setting it down for a reason, right? You can set inventory and placement such that current allocations make you negative.
Yeah.
Which I expect is what they would want to do.
So the way we've done this in other spots is reserved is total.
Sure.
Yeah. But you need to.
But if you've got allocations and you've got a reserve equal to total, you've got a negative total usage, which is allowed. Yeah. But you wouldn't want to block them from marking it down.
Oh yeah, they can mark it down, but we really want to make sure that we never try to consume from it again. If you mark it down, that means you still need to go back to Facebook and say, hey, this is no longer available for consumption in some form.
I think his question was, how do we avoid the race of Nova doing things when the synchronization is happening? And the point is, until it's updated in placement, Nova's going to do whatever it's going to do.
Yeah. And what would happen in that particular case if we do the dark code to compute node, or ACC will say, please assign me a device, and that assignment will fail. And with your late fail at the compute node, it's not ideal, we've done lots of work at this point. But we can handle that on the Nova side.
So just to be totally clear, if a resource provider is being used and somebody goes and removes it in placement, it's called delete on the placement API.
It'll fail.
It will fail? Okay.
If there's active allocations against it.
Correct. Because you can't delete the inventory that's in use.
But you can set the reserve equal to the total to make it not reschedulable.
I'll explain that. Cool.
Sandra, I want to know the reason we want to merge the accelerator DB and the deployable table is that the design of your device side object of the device or the device discovery in your spec.
So right now, if you look at the schema, because accelerators actually devices as we have conceptualized it. The way they are represented to know as accelerators are not devices. They are resources sitting within devices. Devices are resource providers. Accelerators resources, and each accelerator type is a resource class. So if we use one terminology and one set of stuff and use something else, no, I will get confused all over.
Yeah.
And secondly, there's overlap between deployables and accelerators as I understand it today. Deployables also correspond to things in devices, and so do accelerator, table, entries as of today. We can rationalize that in one form and also move to non-PCI devices and do everything in one shot with the stuff that we're talking about. It's a proposal we made.
Ideally, you wouldn't do this in patch. Do this in individually testable things that we do small migrations.
One shot meaning one cycle.
Yeah.
How we sequence it, we can do that.
Yeah, but I mean, what I'm a bit concerned is that if you say you're very PCI based and you want to be less PCI and more something, then the model is like the top priority for you. And all you upgrade from your PCI model to that specific abstract model should be like, I mean, you are a very constrained team, right? And we are talking about the interaction, we are talking about polygon grades, we are talking about all the stuff, and your guys also talking about being more generic and less specific. It's like a big deal to me, just in case of what you have. I mean, just in terms of the resource management point of view. I mean, if you say, and again, I'm talking about priorities, I'm talking about project managed priorities. What do you guys want? Because changing, I mean, I totally get the point that you're trying to model things less PCI and more abstractive. That I'm totally up to, but on the other hand, you're also missing other parts of that, in particular with the grants. So I'm very concerned about the complexity of such changes in the Stein trees, because those are like pretty huge. And if you want to discuss about the model, probably you should take the opportunity while you're all, probably most of all here at the PTG, to discuss about the model, about what you exactly want to change in terms of fields, what would be the steps for changing the field, so that you are pretty clear in your mind about which things you should change in the objects, in the RPC API, in the REST API, and all this stuff. Because if you don't do that now, and like stay vague and just discuss by specs, I'm pretty sure that you won't be able to meet it. Just a words of advice. Just words of advice.
I understand the concern. The way we are thinking of doing it is that we'll have objects correspond to every major piece. So you've got a device being an object corresponding to the resource provider is a deployable inside of database. You have a device identifier, which could be a PCI PF, or it could be a location code for Eric, it could be something else. So we just say that there's one hierarchy of device identifiers.
I don't see any problems with placement, to be honest, because placement is already generic. When I'm talking about when I'm just talking about your web story for having your objects less PCI, I'm more talking about Cyborg specifics. Because placement is already generic, right? You already have resource providers, inventories, allocations. People work out to make that generic. The problem that you guys have is not exactly about how you manage the inventories and the allocations of those things. It's more about how you persist those in your internal database, how you show them in the REST API. Because I don't know about the deployables. I mean, I'm not a specialist of the Cyborg API, but I guess you make a lot of assumptions. And those are probably not like just simple things to change during the cycle.
The deployables today, though, are basically content allocations and placement. The thing that associates this device is being consumed by this instance and the information related to that. Whereas the accelerator is just like, this is a device. It doesn't have blocks. It's going to be programmed to it. It has some capabilities.
Yeah, but you
and you're trying to merge those. So.
I thought you described deployable as slightly different.
Well,
we don't have to explain deployables in summary.
If deployable today is more like a generic object. It could be a PF, it could be a VF, it could be part of a device. Thing kind of using deployables in a generic term.
But it's the thing that's consumed by the instance.
The thing that's attached to the instance, right?
It's part of it is identifying a device. What's a PF? This is what a device is. And part of it is the attached handling to instance, the VF. So everything is getting kind of represented together. I want to kind of separate them out. The device identifier, attached handling, and the components inside.
So what's the difference between a deployable and an accelerator? Accelerator is a thing that has one or more deployables.
A deployable has one or more accelerators. Think of deployable as a device, to put it very loosely, and there will be one or more accelerators inside. For example, deployable could be an entire GPU. Each vGPU instance within that would be a resource from Noah's perspective, and will also be represented as accelerator. That's what we already concluded on the previous PTG. Right?
So in placement terms, the deployable is the provider and the accelerator is the inventory unit?
Yes.
Okay.
I think we
yes,
said
exactly, or yes,
yeah.
roughly.
That's what we pretty much said.
Okay. Yeah. Just if you said it, I didn't understand it, so now I do.
Okay.
I mean, that's why I'm thinking. I think being more abstractive is not really a problem from the placement perspective. I mean, back to our general concern. The concern was that Cyborg is very PCI specific. They want to be less PCI. That we got it. I'm just saying that from the Nova point of view, from the placement point of view, I don't see any problem. I mean, the change could be like only on OSACC and on Cyborg, but from the other placement point of view, for us, it's straightforward, I guess.
Well, I can't agree with that because we still have a big step to go from the PCI pass-through subsystem that's in place today, which is obviously very PCI specific and liquid specific, to something that actually uses placement, which we don't have that plan yet. There's a couple of specs up for that we're going to talk about this week, but we don't really have it.
I agree, but like this, I mean, I think we discussed that during the last meeting, during the last normal meeting. My take on that is that there could be like two efforts, Cyborg on one side and another on the other side. I'm just trying to say that what we currently have on NOAA is a bit unrelated to their concerns. I just don't want like to hold for those people having like the few story just for us to modify what we currently have.
One thing that is there, so there is currently two parallel proposals for how we're going to model PCI pass-through devices in placement going forward. One is the Nova one, and the other is we could do this through Cyborg. Similarly for the BGPs, we would
I know.
And if we eventually implement Nova ones, and we also implement this in Cyborg, and then we decide later that we want to delegate this entirely to Cyborg, we're also going to need to have a way to migrate from one form to the other form.
Well, that's correct.
Yeah, I'm not that. What I'm just trying to explain is that the OpenStack, the OpenStack project is pretty clear about having multiple efforts be done at the same time. That's really not a problem with that. It's more about a problem about resources and time constraints. So whatever the operations decision will be to use either Cyborg or manage PCI devices, it's not our problem, I would say. We are proposing multiple ways to achieve probably the same use case, and there are multiple use cases in OpenStack that can be done by different ways. I'm fine with that. I'm totally fine with that.
Right. The DBM position.
Conclude?
I didn't see this on the agenda, and it's probably, I just want to make sure it gets talked about at some time. And I think what I'd like to see is some sort of staging plan for, you're obviously not going to do everything all at once.
Yeah.
You can't, it's not possible. So, what are you going to do first? Are you going to get just non-programmable full card accelerators passing through in Cyborg by itself, or as a first step, and then later on you're going to do FPGAs, and later on you're going to do SRIOP, and then you're going to start programming. So yeah, it needs to be like there needs to be some sort of a staged plan so that this is going to shoot for, and so that we know what to expect also, like in terms of integration.
Yeah.
Yeah.
Yeah, we did have a plan in Bali. Pre-programmable first case where we're going to need to do the PTG and should be able to put a new one, I will get this to that. We're going to do that. That's what we are. Second thing would be FPGA as a service. Last one GPU, last FPGA put in the top. They go on one. So orchestration does not come into the except to locate the device's right type and assign that use. Also could be what we call orchestration driven programming for FPGAs. Last, let's say, function like IP set. Cyborg, Nova put together, try to find the key. If you can't find that, it comes to Cyborg for programming before the things come. There's a lot of interest on all three of these.
Is this plan written down?
It was written down, I think, in one of the bulky stuff.
The thing that's important to me about staging thing, I agree, like, to me, but I was going to use GPU as an example, but some sort of non-programmed device as the first step seems to make a lot of sense. The only concern that I have is that when you're going to throw the programming into the mix, whether or not we have the kind of integration points at the right point in the sequence to make sure that it gets programmed before we need to do the attach, assuming that has to happen, and whether or not that ends up happening super late, we like have to block the instance until we wait for a callback like we do for ports or, you know, that kind of thing.
Yeah, so you have to be thinking about these things and putting, I mean, at least, if not putting hooks in, at least leaving spaces for.
We certainly need to implement the non-programming thing first, in my opinion. But yeah, I think we have to have where we're planning to go kind of figured out.
The natural sequence of development, things will automatically come first. Before doing anything else, you have to first discover devices, represent them in Nova, and have the end-to-end flow of the lead. So automatically comes first.
So just to be honest, given that Nova already managed the PCI devices and the fact that you can have static devices to be managed with purely Nova, what I'm a bit afraid of is that if you guys go with the simple way of managing on the first time, managing static things and not taking into account how to have this kind of programmable interface, and you make that, I don't know, management API. Then I would be afraid of seeing operators wondering what would be the added value of Cyborg to be installed first, because then they could just use Nova as PCI, as PCI, or any other ways of doing that. What I'm just trying to explain to you is that, if we say that Cyborg is a great tool for managing multiple types of devices, I think all harmonized capability but the way of being able with Cyborg to manage my fleet.
You're saying that's the unique selling point in Cyborg over, because if you just had a pre-programmed FPGA today, you put that more on the Cyborg code, you all right now, the added value is I don't program for you.
Yes, even for GPUs, you want to reconfigure from one pipeline and three GPUs to pipeline 2 and 1.
You need to not necessarily have a mobile file, but you can do that through Nova iCloud driver.
But would that be the best way forward? Would that be the best approach necessarily?
Maybe. Honestly, a GPU is not to be programmable device, just to put that out there. It's a fixed function device that can be segmented. Yes. And that segmentation is distinct from what the kernel that they guess is going to actually run on that. Because that's done by the application driver. When it loads up, case will compile that specific GPU and execute the kernel on using Google, whatever their API is.
Just to make it clear, we can manage GPU types using any kind of configure any kind of CMS if you prefer. From an operator point of view, I will actually try to widen the possibility between deploying an STPI with a specific project and specific endpoint, all this stuff, compared to managing it with Puppet or whatever it is. What I'm just trying to explain to you is that if you want to make Cyborg fancy, make it more than just like a big management system that just does some configurations management layer. Because that's just my personal opinion on that, but Cyborg is the perfect fit for having a fleet of accelerators that I'm able to manage. But when I said to manage, probably having more than just like, okay, I want that specific GPU type on that specific machine. Because if I just do the specific use case, I'm able to do it for the month with Nova and that specific Cyborg.
So that's really clear. Do you see the advantage in representing GPUs using resource providers, resource management, major concept?
Yes, but we can do that in Nova.
We can probably do that in Nova.
We need to do that in Cyborg. Because we have to expect to do PCI pass-through in placement from the Nova side, not just now. It's a very simple extension to make that work with BTG work as well, because it's already tied into all of the same infrastructure as an open code base. So
how would it work for if the Power VM is not showing up as a PCI device? We add it as another
the bug driver can still do this. It
can be all done through the
Yeah, that's the real
deploy the hypervisor API for vGPUs and then just pop it up.
So, like for example, for the moment, you can actually ask Vivian and then to give you a slice of the GPU, and that works. And then you can manage the types using the configuration interface.
So all of that currently relies on, it's all Libra specific. And it's
You
all
got an exam specific that ties to the placement.
right, but the discovery is based on running commands on the hypervisor and stuff, and that stuff is happening right now. It's happening in Nova, not on Virtual.
No, it's happening in the website.
Is that happening in Virtual?
Yeah, and we don't need the compute agent to be on that platform because we technically make the TCP and just create it that way.
Right.
So it's directly analogous to what we were doing with Power BI. We did calling US API to get that integrated.
The reason it's doable with Power BI is because the things that leak out of the bird driver are just placement classes.
Yeah.
Right. But that's a little bit different than, maybe his concern was how you represent generic PCI devices, which would be potentially more of a problem in the generic PCI pass-through case is someone comes along and they have a vendor and product ID that they want to attach. That's harder than vGPU, which is
harder because we haven't coded it yet. Once it's coded, it's a little easier for operators.
I'm saying right now, we don't have any particular way of representing a generic PCI device with a vendor.
What we
All
have-
specific to vGPU.
Right, well, by not just vGPU, but specific to a resource class versus.
But it's fairly trivial to take the existing PCI device table we have and translate that into placement resources.
You mean simple in code, but not simple in PTG to read that.
That's
Okay.
kind of it. Yeah. So basically, it's relatively simple to actually make that transformation if we needed to, just model towards each, whether the product of the combination of different resource class, and we can not use traits model or stuff. We can do that if we needed to. The question is, do we want to invest that in the Nova side or on the Cyborg side? Because there's an emphasis on the Nova side, there's an emphasis on the Cyborg side. We should probably allow the experiment of both to go ahead and see which one is actually better. But we're also wasting resources by doing it twice.
Is it no other specific to PCA pass-through?
It would be trivial to extend this to do USB pass-through or device pass-through as well. We just haven't done it because we haven't needed it.
Once you go to needing events, for example, GPUs.
That's already done in the birth driver.
Yeah.
And we also had a generic library that Minimo that also could just be used to do it more explicitly.
So have you read their Nova interaction specs?
Go back to my virtual comment, so yes.
Okay, so the way they describe it is very prevalent to me, I think, which is that they want to be able to update our whitelist dynamically and then, I guess, request things but through the existing PCI mechanism.
Yeah, I didn't like that either, but that's a implementation detail of how it could have been done. But there was
Used to whitelist in there. I'm not sure what it is.
Whitelist, line 75.
Okay.
Yeah.
Which spec are you looking at?
The Cyborg Nova interaction.rst that is being moved to the.
Okay. You're going to Etherpad.
No, spec, and you remove everything to the Cyborg spec thing, where it's taking all this. I'm just looking at those because they're all in one place, but.
Yeah, that's the Queen's version. That has changed radically by the time we get to the one that's now.
So they're updating specs? Because this right now is up to move.
Yeah, that's moving all of the legacy stuff, but there's also a separate spec to repose the Stein version of this, which somehow has been updating, and that has a very different way of modeling.
Is it proposed against the Cyborg repo or the specs repo?
And the Cyborg repo.
Okay.
Because it does moving all the legacy stuff from the specs repo to the Cyborg one.
So why not
add the
propose
specs that there in the Cyborg?
So you're not proposing new specs against the Cyborg specs repo?
I'm sorry, a little lost actually. I'm not sure which spec are referring
I'm also not sure.
Queen's word, okay.
Yeah.
Way obsolete. I don't even know who wrote it, so I don't know.
Yeah, that's
It's lost.
So,
Okay.
yeah, RSD and all is of interest, but it's not yet in our way.
RSD doesn't require the Cyborg to do the device management either.
OSD itself is effectively just a hypervisor, so there's no reason the WebDriver cannot just call into its API and do the request that OSD will go find the device, add it to the compose node, and reprogram it. So you can do it through Cyborg, but that's the thing. It's like you have multiple ways to solve this. You could say, I am going to require a Cyborg agent to do that programming. But if you have an OSD system that's capable of doing the programming itself, then we can just pass that information, say, here's the bit string, go find it, program it for me, and attach the program device to this compose node, and I will block calling the assembly on that compose node, or actually powering it up until you have done all of that. So again, that can be decoupled from whether it's done in Cyborg or in another WebDriver or some other mechanism. It's a question you can solve when you need to.
Right, we can pick it up later. So for now, we are not saying that we are redoing PCA whitelist and whatever. We could provide a way forward from PCA whitelist by using vendor ID and device ID as traits.
Yeah, that will never get merged.
Yeah,
no, so metadata in traits is something that will never get into.
Well, you're talking about a trait that is custom underscore PCI underscore 086, whatever. Yeah, I think that's probably going to be a little rough as well. But.
Okay, that's what
I'm gunning for it. I'm still open.
Okay.
I mean, why would you allow the driver to post custom traits? Okay, so the J5's argument is that vendors should be providing tables and capabilities according to their devices that we should be able to discover and download into traits that are OS traits. That's a pipe stream. Right? There's no way that's ever going to happen. Right? So until it does, which is never, using vendor product ID as an alias for certain table traits.
That's the whole point of like caring about things as resource classes.
Yeah, so that is the exact use case for having different resource classes. I have a resource class for this particular parent, I have a different resource class for a different parent.
Because ideally, people would never need to worry about like vendor product IDs. That's just like a terrible way to say like I want to SRO VNIC and I don't care, whether it's version 1 or version 2, right? You want a qualitative thing. That's the whole point of doing resource classes. That's the reason that, like,
I agree that would be the ideal picture, saying that I have customers.
But you can have custom resource classes. For anyone who's, you can implement whatever you want for your customers, right? For those devices, right? So I don't understand why.
That's what I'm saying. You're saying that's not going to be non-starter.
Using traits to track this is probably going to be non-standard, but I agree that there is a case that we have some metadata about these resources that we do need to track somewhere.
It's there. It's in the PTG bit stream metadata spec.
Yeah.
So they put it. I didn't understand they are saying they will discover the driver and populate the topology. Where in the topology you have the capabilities.
Yes, but the actual entity power that you can't get those. It's metadata about who meant this thing.
Well, so are you saying we should have a resource class called custom underscore vendor ID product ID?
I would prefer that, but then
How is that better?
because
okay,
if you have the requirement for that specific device, because I need the NVIDIA driver, for example, then I would prefer to express that specific requirement than some kind of.
PCI is covered resource classes. What do you want a GPU with a particular PCI ID? GPU is not a resource class.
So actually, what I discussed about GPUs when discussing GPUs, and that's probably where I'm a little bit stepping aside of that specific conversation because, for example, for the types, we discussed about what's called the capabilities of the GPU. And I think we said, and that's probably where I'm going up for next cycle, to have the driver responsible for making sure, the driver responsible for making sure that we have the threads to be enough abstractive so that there will be like a mapping in between the GPU capability and the device, but not the way we have with like a pure custom trade, and that's basically it. So that's something we know of. I'm engaged to manage that because that's something I'm currently working on. Say, for example, I want that specific header, I want that specific headline and that specific number of I don't know, frame bytes or that kind of stuff. It could be a specific byte managed by the term driver. That's part of the dictionary, and the term driver will be responsible in between what would be the trait ID, whatever it is, and what it corresponds to the GPU capability. But that's the responsibility of the term driver. So what I was assuming in Cyborg is that you have this kind of same mapping dictionary in between what you guys know and what would be the capability that you suppose.
I mean, for the new contract, that's what we had proposed before for the, currently if you do an SOV pass-through by a neutron port, we do a PCI request into no database, and we already are storing the NIC feature plan, so, you know, checks and all that kind of stuff in the database, and the plan will support that just through traits and provider. So that's similar with the GPU. We would want to be able to do that mapping, but the requirement we put on that was that it was the responsibility of the bird driver to normalize the thing up need tool into the set of standard traits, and we would only store the standard traits in the database. And we'd only query against those standard traits. Now, if there was something that wasn't standard trait, yes, you could do a custom underscore whatever. But that would only be a fallback with the intention that we would put that into the standard traits at some other point.
So my take on that is that, and that's something I would really want to avoid. For me, the custom prefix should be reserved for the operators management itself.
Well, we don't reserve right now for ironic, right?
Yeah, I know, but no. Just to be clear, I'm talking about the GPU server side of it.
Yeah.
I will refrain myself to do that kind of shortcut for that and say, if I'm able to do the right mapping, I'm doing it. And if I'm not able to do it, then there's documentation for operators about how they will manage them of different GPU capabilities.
I mean,
if they're creating types, you mean?
Yeah.
Yeah. I think it's acceptable though to also make it relatively straightforward to access the standard traits. Right? We shouldn't make it a really high barrier to get in things like sports APX or whatever as a standard trait.
I don't think that it is.
I don't think it is, but like if we start with the mindset of it's easy to add a standard trait when there's some new standard thing that comes out,
so
then we can avoid a lot of this problem. We just always say we'll wait for the patch that's going to add this new driver and make it depend on the one that does the standard trait.
We have crap ton of traits that don't have any code support for them.
Is that the thing that I was had a patch up for?
What?
Is that the thing I had a patch up for? The compute capabilities?
No.
They're talking about like new devices and not having a real trait yet.
Yeah, so if you go to MediaX 512, MediaX 1024, it shouldn't be that hard to just have a patch that adds that single AVX 1024 trait in, and you depend that will do the mapping.
As soon as someone's got a press release that says that they've got hardware on the market that supports, you know, CUDA version, whatever, or you know, whatever, then that's fine. That's the whole point of it, is just, you know. So
I'm not sure what you're saying. Are you saying that traits should not, vendor ID should not be trait, or are you saying opposite?
What I'm saying is that if I'm able to standardize, then it will be documentation for operators. That's what I'm saying. If when I say type, if the driver is not able, if the driver is not able to standardize the capability into a trait, then it's documentation for operators.
So that is the last portion. Not quite.
It will be documentation for operators by saying, okay, if you guys want to manage a specific capability that's not standard, and manage to do that specific release of OpenStack. Because, for example, for Stein, I will propose you those set of capabilities as standard traits. Say, CUDA library is a perfect example. Say, I'm an operator and I want to specify a specific CUDA library as a trait. If the OpenStack release, for some reason, that will be a design or implementation, isn't providing me the standard traits. There's to be documentation about how to manage that specific trait with placement thingies. Am I more clear or am I clear?
But this was asking about the specific capability of product. And you could also
I'm particularly opposed, to make it clear, I'm particularly opposed to have that specific thing in mind. If the operator wants to manage custom traits, having productivities and vulnerabilities, that's his responsibility, right?
So what if we want to support that use case, so there's one form of it that I actually would be kind of okay with, which is in OS traits, we have a table where we literally put them in. So new device gets released, we get the official fidelity and quality, you put them in there.
Which means we need a code change and a release and the requirements upgraded to support a new device, which kind of sucks.
No, we don't need to support a new device. We need it to be able to just put that straight.
That's what I'm saying. In order for that
to be able to request that device specifically, but we're just saying I want a GPU with CUDA 9 support or whatever. I don't need to request that specific GPU. I just need one that also has CUDA 9 support. Which is what the model we want to get to anyway. We want to get away from vendor new volatility to be able to say these are the actual capabilities I need.
Sure, but I also want to avoid seeing a model where you have to have where you have to change code and make a new release of something in order to support a new device that comes out. I would love to see a model where a new device comes out, it just works. You can ask for it without having to make a code change to do it.
Okay, so rather than continue more on this, because it's often the general economy over time and some stuff, can we add this to the placement depending on, because there's a thing of like what is required to consider placement done. I think there's an edge case here that we do need to address. And we either need to decide if this will be done in placement and here's how to do it, or we need to do this somewhere in Nova and
I don't think there's any placement work that's relevant to this.
But like there is a placement model in terms of should we be using traits to model this kind of stuff? Should we be using resource passes to model this kind of stuff?
Right, none of that's placement side discussion. The placement API already supports that.
I think it's a recommendation that the placement team should be making so that we don't take it an approach from Nova versus Cyborg versus Cinder versus whatever. Right? Recommend how do you model this using your existing API.
Okay, you're right, we should talk about that.
Can I bring up something else to share some time here?
Hmm?
Can I bring up another topic
For what?
or more discussion?
Well,
So I have a general question, let's read the first one question. If you have two projects, right? One project wants minimum version of certain package in general. Another project is not able to handle that. How do you resolve that in general?
That's what upper constraints, that's what upper and lower constraints
Yes,
for.
but-
The requirements project is where you would resolve that.
so yeah, an official project is not allowed to use a depend on the version that's above the upper constraint, so
Or below the.
or below the one.
But how do you decide upper and lower constraints?
You propose a patch up to yours and then go ahead.
Up to asking up to Nova?
No,
To the requirement.
But possibly also to know, so in Nova, you would specify a lower constraint. In Cyborg, you would specify a lower constraint. And then the higher of those two is going to be the minimum that you can actually run with. But both of those are going to have to be less than or equal to what's in the upper constraint.
Which is in requirements.
Which is in requirements projects as a global stack.
There's also, as you're aware, I think we still have a blacklist or something you're not allowed to include. Yeah. So no broken things. So if there's a line view you're thinking of introducing, it's a very good idea to check that. The gate should actually comment if you have the right job set up. To say, hey, this was a blacklist of thing and it should scale the requirements checks. I don't know if you've actually done that in Shieldproofing to make sure that that runs when you're in your gate job and emerging stuff. But it's a good thing to run if you're changing a law so it's got requirements.
Okay, let's moving on.
So just to consider the vendor ID and vendor ID, product ID. My take on that, and probably that's why I'm going back to the specific question because I think that you probably misunderstood my point. When I say, for example, for the virtual GPU that we currently made on the work, When I say if I'm able either by design, if I'm not able either by design or by implementation to know to provide the traits to placement because of that, that means that, for example, for specific director, I will make my responsibility when I say I as a developer, to provide all the QLM numbers and all the stuff by number. I will just, for example, I will try to guess because I will have ways to guess, for example, the northwest or other stuff that I'm going to document it. But for the specific objective is that my library is not giving me. Then it will be documentation for operators. So it will be their responsibility. They could write their own script. It would be possible writing a script or managing a specific color project. I don't really care about that. What I'm just trying to explain is that they could having some kind of introspection mechanism that would get the variety and product ID. Or NVIDIA could do that if they want. They could run some specific tool that would translate the product ID into a specific threat. Call placement, asking for those specific threats and all this stuff. I mean, I don't really care about that, but what I'm just trying to explain to use that is not, for me, I'm really commenting that managing that in Java, except if I'm getting it from the legal information that I got.
So in short, you are against it, the object they do it, they just don't want it automatically.
Yeah.
So that seems a very fun distinction.
Well, it's very specific, right? It's very specific. The information that you will say is very specific. And one bit of highlight is that, you know, it's kind of an implementation that you can import. But it's not very private specific information. And with some specific or reverse releases, you could imagine some non-backwards compatibility, that kind of stuff. So that's why I really don't want to have that managed in Nova, just because of that. It's their responsibility of the users if they want to have their own tool managing the discovery and then the creation of the trace. I'm totally fine with it, but then that's the responsibility of that tool.
Okay, so let's back.
Before we move on, I just want to add some comments regarding the staging, like the stage targets. I think currently we are kind of getting blocked by the finalizing the spec with Nova folks. I hope we can get this one finalized. Otherwise, all of the other things is just nothing. Because otherwise, the Cyborg is totally in unusable state. Yeah. I just want to add this one.
Yeah, so to tie that together, right? Someone was working on a Nova spec.
Yeah.
Well, that's going to be in the Nova specs repository under Stein.
Yeah.
So it should delineate the scope of what you think is going to be accomplishable in that release time, right?
Yeah.
So it shouldn't be about the whole world.
Yeah.
Programmable FPGAs and splitting up VS and getting networks attached and all that. You should talk about just what you think you can accomplish in one of these.
Yeah, that's important.
So,
okay.
Do we have an agenda or the timeline for the?
We can discuss it in the afternoon, I think. Okay, moving on the agenda. Under the fine tuning, who proposed this? Sander, did you propose? Is it from Jinghan? Over. The old drivers setup question and remove ACC create delete API. Or from Shaohe? Do you know that?
That's from Shaohe.
From Shaohe, right? Yeah. Okay.
So we can. That's great. Is this touching on the idea of will all possible Cyborg drivers always be installed, or is it just having to be subset unique of one platform?
Yeah.
There's a setup.cfg. Operator can set up whatever is called that.
Well, so it depends. Most of the platforms are just the moment the drivers need to be in particular repos, so you actually need to have them in Cyborg tree. So going forward, your plan is to allow external repos to have additional response, provide a vendor-specific, say, GPU driver, is that correct? So they'll be dynamically loaded based on what packages get installed on the system, rather than all being in tree in Cyborg.
Exactly. I think it's important to pull out of tree drivers.
Mm-hmm.
Like,
So one consideration you have to make with out-of-tree drivers is that the data model that's expressed across that needs to remain in Cyborg core. So a out-of-tree driver will be able to introduce a new accelerator type. But it can introduce a implementation of consuming or configuring that accelerator. Right? So to have a very clear delineation about the resources that are in the core, and then the drivers just do the implementation of that specific.
Yeah. Yeah.
The agent to driver API is getting documented, it's specified. So every out-of-tree driver has all the same spec.
Yeah. Yeah. Should be done this way. Okay.
Should the user confuse? Can user confuse or can user choose what kind of driver we need to use?
I would think no, because for the drivers we're talking about here are the ones that are sold on the platform, right?
Yeah.
So the end user is not going to know what operating system the cloud is deployed on. Even if they did know the operating system, you don't want the end user to be able to inject out-of-tree code in. What? I know, right? But so that basically means that they probably shouldn't be able to see on a specific host what drivers are available or ask for one to be loaded.
Yeah.
When we're saying we want X driver to be available, we should be filtering on this and finding the host that has it available, rather than actually allowing them to do that basically. You can maybe the second question, which is like the accelerator ratio to be from the user.
Yeah.
I'm assuming that's whitelisting a device that can be then used. Is that correct? So I'm saying via the API, the GPU of this vendor topology at this address is allowed to be consumed as a deployable. Is that what that API is doing? I'm just not familiar with what the accelerator creation delete API command actually does. So is it listing the device that can then be consumed?
I think that should be deleted because the accelerator it's discovered by the agent or by the driver, and the agent periodically retrieve from the data from the driver. So I think that shouldn't
and I guess
update by the user.
Yeah, since the agent can toggle the RPC bus, you don't need to have a REST endpoint to allow you to do the same thing, right?
Yeah.
Okay. Moving on, the runtime programming, that's from Sander.
Yes. So this is going to take some time. We want to do that here.
Maybe we'll skip it. If it's lengthy, we can do it in the afternoon or tomorrow. Yeah. Okay. Next, more driver support. That means for the Stein release, other than the GPU and FPGA, those are like for sure we'll be focusing on. I think we'll be looking for like more drivers. There will be Xilinx. Xilinx was like slated for Rocky, but there's staffing issue on their side. So we'll be looking forward for official Xilinx support for Stein. But unfortunately, their people are not present here, so we'll talk to them for another separate offline discussion.
I don't need the Xilinx guys. We make sure what are they writing the specs works for them too. We are making assumptions on that.
Yeah.
So just a question on adding new drivers. Back to the governance question we had before. Are you today requiring spec for that? Or is this something you just say you open up the blueprint so you can track it, but provided you're not adding a new type of accelerator that you're allowed to add in the vendor-specific plugin and that support?
Yeah, we don't require a spec for driver at the moment.
No, I think that makes sense.
Yeah.
A spec, I think, too heavyweight to say.
Yeah.
Intel version versus our into it.
Yeah.
That blueprint should be enough
Yeah.
to just track the activity and then macros those are not ones.
Yeah. So another type of new driver support probably will come in Shine is about NPU. Artificial intelligence. There's big hype and requirement from the customer at the moment. So at least from Huawei, we have a new NPU product out. So we have probably we will have a driver for our NPU for Stein. Neuron processing unit, yeah. Yeah, I think so.
For AI training?
It's basically the same thing.
Yeah, it's just ASICs. So, well, anyways, it's so. If any of you have like your company interested in like driver support, feel free to suggest that, and we'll be looking into that.
The other thing I want to add is I was talking with the UC Berkeley folks about their RISC-V processor support, and they're interested to make it available for OpenStack, but still need further discussion on this. Yep.
Okay, so the last item for the morning session about more architecture support. The first one is RC, I suppose, from Sander. No, the RC. Yeah. Yeah. No, you can talk.
You can create a distributed model, predefine transport all of that, and then start something. What multitasking are today. In the future, if you want the workload itself to define that go have been composed on the fly, you need to do how we will switch.
Okay, so dynamically compose.
So when you come up with your integration, it goes to Cyborg. So you have first collateral and lower static node, and then you can put it in private node before we can do policy itself will allow you to dynamically concatenate these devices, or this how to expand it. So a VM request comes in or an instance request comes in. How to do eventually focus that on the fly with the requirements.
Okay, so like what's needed for Cyborg in the short term? If for Stein.
Okay. Yeah. You get the short term means Stein everything through the knowledge, most of the architecture. I'm not sure if the implementation.
Okay.
Basically, share the source provider. So you have share and nested the source provider.
Well, placement is already there.
Yeah.
So to do that correctly, you would have your sled of FPGAs represented as a sharing resource provider, where you use an aggregate to associate to the compute that can be attached to, whether that's over some fabric protocol or it's a backchain and you've got the widget. You need to model that in placement as an aggregate to say people want this side, we associate to the compute those that you can
Does it share nested
So this would be a nested resource provider. It could, in theory, depending on if that thing has multiple providers, but it could just be a standalone resource provider on the FPGA. It's associated with the sharing provider. The
things underneath it, but it's not underneath it.
It's not
different design stuff. So what I want to know is from different concept.
A provider may share resources by aggregate. So that aggregate association is flat. provider. The nested modeling is to demonstrate the structure, the relationship between provider and providers and child.
You would have to tag all of the aggregate and with the shared.
Right, I mean, if one provider wants to share resources with any other provider, they can use an aggregate association. There's really no reason to use nesting unless you want to specifically state there is a parent-child relationship between these providers.
So in honesty, there is a use case for that, which is I could write for crack scale design. So the use case for that is I have an RST pod. It has multiple different things it can share. So it has compose nodes, one after the tree, and then you've got these sharing resource providers that you might want to associate with the actual hard parent node. But you don't actually need to do that association. If you want to do that in the tree, you can just use an aggregate association. So it's better to keep the sharing things as
Yeah, the way
separate
I've thought about rack steel or any sort of composable architecture is more you've got pools of like resources, right? And that's really what the shared resource sharing providers stuff is about. Really, I don't see any need to get the nesting model stuff.
Another one with the design here. Hypothetically, this is a model thought experiment. Let's say my PGA is shared for it's shared on multiple compute nodes, one at a time. With my PGA with multiple regions, which are there's not nesting concept. Right. Your accelerators are sitting inside those regions. That's what inventory is.
Yeah. So you can combine these, but you don't have to. It depends on how you choose.
But each region is each region providing a separate pool of resources? Or is the region itself a slot that is the resource?
A region could consider provide more than one accelerator.
So if you programmed in, say, an IPsec function into that region, you could subdivide that up and back with, it may only be able to like touch a few IPsec key pairs or something like that, but could then have a consumable resource for each one and have those attached to different posts.
Yeah, I would stick with just the generic sharing providers. Okay. Unless there's a very specific reason you want to model a parent-child relationship. And I don't see a parent-child relationship here. You're just sharing it between multiple people.
Well, in this particular case, you have the FPGAs coming out of a pool of FPGAs in a particular drawer, and then he's pulling the function into that, and he's sharing that function to multiple things they can be shared. So there is a use case for it, but I would maybe just get the basic one bucket.
The parent-child part doesn't matter.
Yeah.
Yeah. No.
That's Jay's point.
Yeah.
So one of the points I should probably point out is that if you model the entire single resource provider, and then treat everything as identical within that, not quite be the case with programmable devices, because each one has been programmed differently.
No, but you have multiple resource providers here. You have, if you're doing this sharing, you've already consumed that device and you've programmed in an image. So you would really want that to be a separate resource provider sharing out other things, and you can have its own aggregate sharing relationship.
Yes, so each FPGA device by itself would be a shared provider.
Yeah,
absolutely.
Once it has a function in it, especially if it's got a non-zero,
single assignment.
Yeah, then it needs to be its own provider so that you can share.
Okay, that's not the question. So once each FPGA is separate provider by itself, it's got nesting from that. So
no, you really don't have to do the nesting thing. You want to think that way because you know that it's nested, but it doesn't matter.
Right.
So just don't worry about it. You can do it if you want, but it's not.
So you say it would be its own shared provider by itself.
Yeah. It's like you created by programming an FPGA with an image or whatever, you've created a device out of thin air basically that now has attributes and now provides resources.
And you specifically don't want to use nested resource providers because that really was designed for a compute node resource provider as a root, and then the SRO NIC or the NUMA cell is a child of that. It's dependent on that compute node root provider. In this case, any provider of resources where you're providing to multiple compute nodes,
So
here's
here's the thing. Where it does matter is if are doing something like IPsec maybe where you need a network port out of the drawer. And then you need an FPGA program for IPsec out of that same device so that you make sure that you get them that are physically connected. That's where trial.
Although we would do that through aggregate. So the network port would be, you'd select that out of an aggregate, and then you provide that aggregate in your.
So the point is, you could use nesting here, you may or may not need to, depending on your constraints. And it should be up to the device or the thing that's modeling it to understand that relationship and actually represent it in Facebook.
So correct. So I was about to say that with virtual GPUs, we are about to nest things. In which specific case?
The GPU, the reason that the GPUs are nested under a compute node group provider is because the GPUs are specific to a compute node.
Right. To be clear, yeah.
Right.
To be clear,
in this case, the IPsec program can be given out to a VM that's running on some other compute node because of the composable design. Right?
Yeah, but if that FPGA has to talk out a port that is in a drawer and not compute node,
Sure.
right.
or has a head attached for a GPU if that were there or something like that.
Could you model this with nested? Yes, I think it would be easier to not.
I don't think
You could
we
model
should-
nested with aggregates.
Yes.
But
In this case, I would just go with the simpler solution. That is
For the GPU case or for the port? I don't understand why it becomes basically the same kind of query that you do for a compute node, right? You like, I need memory and disk, but I need them to be all within the same piece of hardware. And for the IPsec and
it's not the same piece of hardware. Multiple pieces of.
under a compute node, if I want memory and disk out of one compute node, I say they need to be within the same.
well, with a single resource, that's good for that.
But I view the port thing and the network, within this tray. I view that very similar to the way that we handle routed network segments, right? Which is we pre-compute and say which you've asked for this port. Which routed network segment is it in? Which aggregate is that routed network segment associated with? And then we use that in a number of queries. So
that works because you know the number of before you're doing scheduling. When you're going to boot an instance, you don't know what compute node it's going to be on. So you need to say, I need memory and disk that are under a tree, and I need IPsec and a network port that are under a tree. And that I don't think you can use aggregates for that because you don't know where it's going to land. Well, you don't know where it's going to land, right?
We'll need it to change providers for other simpler use cases as well in terms of like just the storage case.
Sure.
Right? Because if I'm doing a migration, I need to make sure that I can window down to another one. If I don't want to do the copy of the data to another one that's in the same aggregate, I suppose everybody knows that point. But
Just to be totally clear about one of the previous remarks, right? Because RSD is not in the picture. The FPGA is directly attached to the compute node. There are no points modeling being nested
That
between
should
the
be nested.
device.
That should be
That
nested.
should be nested.
That is nested, yes.
Yeah, good. That's what we said.
Yeah, I mean, my personal opinion about RSD and composable architectures is that there should be a compositor that pre-composes things that look like compute nodes instead of having these giant pools of random.
No, Jay, it has to be dynamic.
I know it
has to be dynamic right now.
well, there is actually inside that design. It has a thing that will do that.
I know,
It doesn't do what you want it to because it gives you a minimum instead of what you ask for. Right. So that makes it more complicated. Yes.
And more complicated generally is something that we should.
And so this complexity at the most related inside what I was the Cyborg project that's doing that competition. It shouldn't leak into the rest of Nobel.
Well, the Cyborg isn't the thing that's doing the compositor, right? This is separate. It should be a separate thing. What do we call it?
That's usually no balance isn't a thing anymore.
I can.
Yeah, it's Monday, it's not a thing anymore. So Tuesday might be a thing again, but.
The Cyborg isn't trying to be a compositor for RSD.
Not in general. I think RSD were trying to do overall composition. Cyborg is involved only for accelerators.
Right. Yeah. So it's not trying to compose these things that look like compute nodes. It's just
No, but it's
inventorying accelerators.
But it's saying,
programming.
take the acceleration, put this particular function onto it, and then allocate it to this other component.
It's a very similar action, right? You're creating devices kind of that didn't exist before because you programmed them to do something specific.
Yeah.
There's another architecture that could be supported. It's a complicated one. Maybe not as we want that one.
We want the one.
So the recommendation here is what? I mean, what are we recommending to society?
The recommendation is that this is many years down the path, and like I'm guessing.
Well, now we have reshape it. We can just reshape it all the time. Whatever.
Yeah, you missed the part about a lot of stuff.
I'll show it.
Okay. Yeah. Moving on. Next, late assignment. Who's this
Can you
from?
say it again, Howard?
The next, like
Late assignment.
late assignment, assign one or more accelerators to a running VM.
Leave it as part of that one. Sure.
Yeah.
Basically, the game is already up and running, then you start attaching it. I am not sure if this is other certain important use case, it's being it up because what we want to do. Typically, when somebody comes up and say they want in 3 months, we start thinking ahead of time.
Hmm.
So, you define a flavor with the accelerators, drop the VM, and now the user says, no, I want to attach it.
Yeah.
You could build a mobile interface attached for things like ports, but how do you build the accelerator?
So I was gonna I was thinking about this the other day about what the terminology is that we speak kind of when we're wanting to attach something that could be one of a billion possible things. I wonder if it makes sense to maybe have a attached device call like attach volume and attach interface, but that takes resources and traits. It says I want to attach a device and IPsec equals 1, use multi-queue something or other, like that's like a new resource class and count. And
Why would we need the traits?
so because I want to attach, well, think about the disk case. I want to attach 32 gig of storage. Well, I want it to be SD or whatever. So I need to, I'm saying I want a new device and it needs to have this much capacity and needs to have these traits, kind of like you do on boot, right?
I would,
So I
I would push back pretty hard against that versus predetermining via either a fault placement or something else, which particular device you want to attach, and then just passing the device identifier.
Well, you can't do that with placement because placement doesn't know what those things are.
And you can't do that as an end user because I shouldn't know what particular PCI address is.
Nor can I see a placement.
So
No, I'm sorry, you're misunderstanding. I'm saying if you have, say, an SRID PF that is a child provider under a compute node, you can ask placement, tell me, here's a set of traits and resource classes, whatever. Give me the provider ID, PUID, that matches this particular request on this compute node that I'm already on.
sure, yes.
No one can ask that.
No, Cyborg or whatever can ask that.
A user can't pass that.
An end user, right?
Yeah, so that's what we're talking about, is giving the ability to have an end user say something like, say OpenStack server attached device and some pre-created like device flavor that has the resource class, the traits, it goes to placement, it looks at what the node that's already on, it finds that resource provider, then we pass it down to the bus driver or Cyborg, it does an assignment of that, and then we get back the attachment and we give it to the bus driver to generate the XML update and it you attach to the device.
I broadly agree. One thing I would say is what we use is the instance UID and the specification of the accelerator.
Oh yeah, well, that's
the
like
server
attached, server UUID, and then the operator created thing that lists the resource class and the things that we can be building. Right? We want to keep that we don't want arbitrary traits in because that means I could put in a trait that that would
restrict it to a particular host, so you can do some.
You've already, I'm sorry, what about, no?
If we do this, I would prefer if we had the same syntax for doing the device attachment boost as well. So he does do that, dash dash device, here's the thing, so we don't have a disparity between the hard attach case and the first boot case. First boot case, we don't want them just specify that.
The way that it was designed for the NICs, for ports or whatever.
Usually SOV.
Right, was that the port profile had a network capabilities debt, right? That had a bunch of required traits and
yes,
can have forbidden traits or whatever in there, along with the resources dict that said I need SRIOD, via count 2, whatever, 1. And then that gets converted into a port binding request, or sorry, PCI device request.
Yeah.
That process of converting into a PCI device request requires an interaction between Nova and Neutron. So what you're recommending, the two of you, is that there be a interaction between Nova and Cyborg to get the resources, traits, and blah, 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 like just a generic device request?
No, it doesn't need to be that, right? If you want to attach a device that has disk GB equals 32 and SSD as an attribute or a trait, I can go to placement and say, it's got to be under this tree, can you give me that? And if it can, then it says cool, and then it can go down to the compute node, can then say, okay, it's a disk GB, I'm going to talk to sender and request it and do the attach.
So I think in the Neutron case, we actually merged that code for the Neutron port case because there was ways that you could have used it. So I abandoned that spec in the patches are, and the intent was to have an outdated way of allowing you to describe that. And in the Neutron port, I would say here's the device flavor for that Neutron port going forward, so that it's not arbitrary traits of injected by the end user.
Sorry to make a political second, but something is clear in my mind. If we talk about data assignment, that means that, say I want to boot a server, I'm a user, I want to boot a server, and then I want to attach a GPU or a FPGA. I want to attach, let's say, a GPU. I'm going to ask to attach my GPU, but how can I make the assumption that the GPU will be present?
You can't, but because of the placement tree, we can build in the API. If data comes back and says there's nothing in this tree that matches this request, we just have to the API. So people
Okay,
that.
I get that. We can actually, programmatically, we can determine whether we can attach or whether we cannot attach. For me, that's okay, but on a large cloud, you cannot really make assumptions that an user that what you ask will be okay for you. What I'm just trying to express is that there are more chances that you won't have the hardware than you have.
Yes, that's true. And there's other constraints as well that we don't need to go together for the SW case. I might not have enough free PCI slots in the VM, so I may have to fail up because of that. That's slightly Libvirt specific, but I may not be actually able to attach it to the VM.
There's always going to be
and the system itself. All of that is kind of not to mention the main question of is a device there?
What I'm just trying to say is that if you consider the probability that you won't end up very well, that makes me thinking that as a user, I won't be probably using a lot of this. We prefer to ask to create the instance as of now as having all the assignment to be done at creation time.
Yes, you would think that. But for certain use cases, specifically, we want to attach an FPGA to a particular image to do some computation, and we have to attach different ones to the same thing. Maybe the same device, but we want it to be programmed.
Okay,
to isolate use cases.
Especially in the cloud where the resources are rare.
So this is
I'm not quite sure I get what the concern is.
My concern is that when discussing about a scheduling decision, whether the instance can be, whether the host can be accepting that specific request.
It's not really scheduling though at this point.
We only
You
well,
can't,
on the note.
you can't use allocation candidates practically, right? You can only use find resource provider in tree with this resource and then build an allocation request out of that and then ask for it. And if it fails, it fails. And you fail to the user. If it succeeds, then you got that allocation and you go to the attach. And maybe you fail late at that point and maybe you don't have to
There's
find
no
it.
fail late in any allocation claim.
No, you fail to attach.
doesn't attach.
And then you have to unwind it and get rid of the allocation.
Which is kind of what we're trying to avoid.
But it can always happen.
Right, but it can always happen if you, right, so what Sean was saying, there's no slots left on the VM, whatever.
My concern about, so I see this working pretty well for some sorts of devices, but Dan, when you said things like, I want to attach, 32 gig of SSD or something, how are we supposed to differentiate that between the disk GB resource request that the original VM had?
Yeah, you can't,
We'll have
disk GB is a
So what
different.
if the root disk,
we can
whatever.
differentiate this fairly easily.
And
This
you're-
is the fact system request group. Right, we'll have to update the original instance request object to say this is a different thing, but we can do those additional request groups as allocated separately.
We just need to, we're not gonna do an allocation candidates thing, we're gonna do a get resource providers that have an extra 32 gig of stuff, and that's gonna be a new allocation against a particular provider, right? I mean, it doesn't.
What's the consumer going to be?
What we're gonna have to do is go back to the instance and update its
So you're gonna have-
allocation.
Correct.
Okay.
You're gonna have to post the allocation.
Yeah.
All right.
The reason is, one option is to say, in many years from now, where Cyborg is the shooting star of all device everything, and we rip out all of the PCI stuff from Nova and GPU stuff and SRE stuff, as Cyborg can do it all for us.
Praise be.
Thank you. You get to this point where if we don't do something like this, then everyone's going to have to go to Cyborg to pre-provision anything. You get this situation that we have with Cinder and Neutron right now, where you have to go speak to this other service, pre-provision all of your devices, get all of these opaque device identifiers, and then pass them in to attach, which is one way to do it, for sure. I just, like, all the battle scars from everyone complaining about this for the two services that we support right now makes me think that that's not going to be super palatable. And what they're talking about is an infinite number of new device types, whereas with Neutron and Cinder, they're networky or just. So that's why I was just thinking maybe it makes sense for people to communicate to us that they want to attach a generic thing, a resource class, and not necessarily have to have them go to Cyborg and pre-provision a bunch of things.
And I like that idea too. We just have like a validation step in place.
Yeah, I mean,
To be able to fail fast.
I totally see it with, NICs and GPUs and I'm having a little bit of a brain fart trying to figure out how
On the disk, it says
the
disk,
disk,
like,
logical resources would be, but I guess if the provider's different, I guess you'd have a separate disk provider than the computer?
We don't have that.
We'll
We'll talk about disk. We can't do that right now. Okay. You can't have two separate disks on the same storage provider today.
Yeah.
Right.
So you could.
Where I'm getting into this issue.
But
eventually we're gonna have to have that.
So the disk use case is actually very simple. I'm taking my normal storage and say, look, I might want to be able to say that the local Octane drive.
Absolutely.
As a
We
cache.
just don't have the ability to do that.
Right, so
That's
so that would allow us to literally say, please give me an Octane drive and the free subscribe space on the local domain. Get all of my other storage from Cinder, keep all this system state there, and we have a relatively clean.
So I don't mean to rail this discussion, but how does that come into this Cyborg?
If Cyborg is going to be generic device management, not just accelerator management, we would want it to be able to do this kind of a request from the server creator attach rather than.
Well, or that pass through the disk.
Yeah,
No.
you can.
Thanks, Sean. But I'm trying to say if we can get to a generic where we basically.
Where it's just attached device.
Yeah, we've deprecated attached volume, we've deprecated attached interface.
Attached resource.
We're
Not even attached device, but attached resource.
Fine, sure, but that's what we speak, that's the term that we speak in that call, which is a resource class and a set of,
Instead of attached, I'll add resource requests.
Yeah. So the disk wouldn't come through Cyborg, it would come through Cinder, and the network would come through Neutron, but if you ask for something weird.
Deprecate the attached interface, attached, volume. In favor of this new, just generic, which is, the attached volume and attached interface do what we're talking about, just in coordination with Neutron or Cinder.
Right.
What we're talking about is basically just have the end user supply the.
And hopefully that is
Constraints.
the last attached call we ever have to write, right? If we start talking about things in terms of resource classes and traits going forward, you know, when someone comes up with whatever the next weird thing is, we hopefully.
Although, yeah,
I mean,
each different type of device is going to have a separate attachment process.
Yeah,
From
but
a
that's,
resource management perspective, yeah, we can add a single
I
add or remove.
still don't see what that's going to say.
because that's
we're
how we're
talking
gonna.
about how to actually have Cyborg interact with this.
The topic right now is how do we hot attach an IPsec accelerator?
See?
And so,
Right, but attaching an accelerator, going from attaching an accelerator to attach a device, to pass through a device, is a fairly short step. Going from attach a device to attach any resource generically, I think is a much bigger leap. Like that's a,
Yeah, but
In
what
terms of-
Dan's
in terms
saying
of
is he
scope.
doesn't want to add attached GPU and attached FPGA. And he doesn't want to add one of those for every single type of infinite number of.
like we do for Get Console, Get Twice Console.
Right, yeah. He's just proposing a more generic way of passing the parameters and constraints. Do you just feel that we've gotten off track by being generic?
I think we're taking being generic and step too far with that.
If we constrain it to pass-through devices and not just to, I want to attach a new IP to this thing, is that more comfortable to you?
Yeah. That sounds like it's more in scope of what Cyborg intends to do ever.
Then we could just name it attached device rather than attached resource class.
I
To
mean,
indicate that
well,
it's a consumable thing that will be attached to the instance.
Why
What if it's a new CPU?
You can do that.
That's fine.
We don't have a way to do that right now, but it would be nice to be able to do that. People want that.
I think
No. People want the library side. This actually could replace library size as a new call, right?
Yeah, and you can do the detached CPU outputs as well. You better.
Although, we're getting it into issues of downsizing, never good.
Sure.
Upsizing.
That's everything, right?
So far, at this point, we've planned to like the next R release.
I get your point.
No.
So, Cyborg, people, what do you feel about this? Is this, if Nova was to go into this direction with the new API request and you could delegate it to whichever service is responsible for that resource type, so Cyborg or Neutron, whatever, is this something you would like as an end user experience?
It makes sense to me. Like, we ask for a resource with some traits and qualifiers, comes to Nova, goes to basement prepares a list of potential candidates, the same compute node.
Yep.
Right? Comes to Nova scheduler, if it's a specific one.
No. Scheduler doesn't do that. No, you were on the right track until that point. So,
What happens after placement prepares?
Basement sets gives an allocation candidate for that request. We give it to the compute node. It gives it to Cyborg by OSACC or Neutron by whatever. And then it does.
List of allocation candidates. What do you do?
Don't worry about that.
Yeah.
That happens to determine which compute node you go to. But once you're already there, which is what we're talking about here, right? You need to just attach a new device. We don't actually go through the allocation candidate or the scheduling process.
Okay, and we don't pass the allocation to the compute node. This compute node, we need to claim it before we get the compute node.
I phrased that incorrectly, but we pass the same thing to the compute node. It's the thing that figures out how to do the assignment, because basement person does that. Like I put 3 things. It chooses which particular one is the corresponding one, and that can be delegated to Cyborg in the case of the FPGAs, it can be delegated to something else.
Yeah, I mean, it doesn't necessarily need to be the compute node that makes that decision. In fact,
wouldn't be.
we wouldn't really want to send it all the way down to the compute node,
No.
just make that decision in the whatever.
Exactly right. So then,
But you use a certain of the conductor will choose which specific specific.
Yeah, it doesn't matter.
It's easier.
It's the first one. Like, it doesn't
Just
matter.
choose, because they all meet the requirements,
Exactly.
the constraints.
There's
And
no-
after that, we're getting into sorters and wires and.
Right. And when it matters for affinity and we are able to model distance, it will still be the first one because it will have sorted them.
Okay.
So we then would need just a limit on which devices which resource classes are attachable via this thing. So you can't go right now attach vCPU and you can't attach an IP and that kind of thing. So the operator can say, I don't want them to attach anything like this.
So you know that scheduler config because these are the ones that can go in or somewhat place. It could be in placement or something.
Not scheduler config, but in the Nova config, yes. These are the resource classes that are attachable.
Yeah.
The default is empty.
Just to be clear, so Nova selects specific resource provider. So it looks just like a regular assignment.
Selects a tree. Well, I mean, placement returns a list of
That's
things that.
list, but Nova connect something in Nova selects one of them.
No one has to do a claim on the first one that gets in that list, and then we have to pass something down to the compute node.
And after it's completely generic, if it happens with neutron, put it up to neutron, it happens to be answered with Cyborg.
Depending on the resource class.
Right, yeah, okay, excellent. Sure.
I have one question about usability. You expect that the end user will know the name of the resource class, name of the traits provided to know anything.
Yeah. So that's the other thing about this is that we have to be able to allow them to list traits and list.
Well, no,
resources.
actually, we don't need to. We could do it that way. The other way is to allow the operation have a kind of device flavorly thing that just hands those things to people and then the operation can say, here's the thing you can request. It's called a SRD port. And they've encoded that. We never expose what the actual.
They do that in the flavor right now.
But we do it as a separate first class thing so that we don't need to have that flavor explode. It's just a device flavor for the thing that gets passed through.
You're talking about a new top level device profile
Yes.
object in Nova.
Flavorless.
You can, but like that's the way to make it not explode, right? I really don't like this. It's come up like 4 times, but it's come up for 4 reasons.
Yeah, I know. I hear you. That's a whole big other thing.
Okay.
Yeah, it's certainly not a requirement for the first.
Right.
But you've got 2 options. You can now the end user specified resource class and the traits, meaning we now need to have a non-admin API to list out both of those things.
We don't need that. We could have that. Or the operator could just kind of define it in their docs as these are the things that you're able to attach.
And now we don't put anything to the stuff of the API, so.
I'm saying as a first like usable thing,
Okay.
it can be easily documentable. And then we can figure out whether that's going to be by role or whatever else.
So yeah, that is something I wonder. If we say there is some way to attach the device, that means that, for example, say a virtual viewer would be able then to request a late attachment, a late assignment. Okay, that I understand. But then, what if, I mean, okay, that's probably just an information detail, but what I'm a bit wondering is that for the time being, we consider the flavor as the sort of proof for knowing what the user wanted.
If no devices are in the can attach list config that I was saying, then you get whatever was in your flavor resources and that's it. You can't ever add anything to it, right? So one other way of doing what Gibby was saying is that we could have a get/server/TUID/available devices and return a list of resource classes that can be attached to this.
So just the way names and you choose and
which might be things that the vert driver supports or doesn't support, or the compute node doesn't have any GPUs, so GPU is not in there.
I would assume though you don't want that to download to the computer node, you want to just have this pre-detail or?
You can do that in the API to look at placement without talking about it.
Sure.
Does it have any available inventory? What?
Yeah.
No. Nova can, on behalf, if we do this API, Nova can query placement to see what's available on that computer.
Yes.
Sure, but again, back to my question, what if I'm resizing the instance?
But
Do I
besides
lose
that,
do I lose my attachment?
no, you have to, we don't want to update the original instance request, because we want to set that what it is, but we will need to put something into it.
So we'll have updated the allocation.
Okay.
When you got the new thing, we updated your allocation to include the new thing before we ever even got involved.
So we stopped using the flavor of that.
Well, we just need to make sure on the migration, we don't just recompute that allocation thing. We need to preserve what was in the original one.
Well, actually, instance has its own flavor, so we could add it to the instance's flavor.
But
They
the
have,
actual.
no, it's not cached, it's the instance.
What's that better?
Okay,
Yeah.
that's my point. By some time, we will modify the instances of flavor just to add a specific element. Okay. Okay.
We kind of already do that.
Yeah.
Okay.
And that's what we're gonna do.
Anything that's in the resources dict of extra spec, in the flavor, we flatten that out and put it in this.
But right now, we only do that on spawn. We don't update it again on migrate.
Yes, we absolutely do.
Yeah.
Yeah, on resize, we update the
Sorry,
flavor.
on resize, yes, but.
Migrate, well, it doesn't change on migrate.
No,
Yeah.
on attachments.
Attached interfaces in your
Yeah, it's not
flavor.
resources in
Follow question. So
This is the last one, Gibby, so.
Sure. Last one for later. So I tend to like what Sean said about having some entity on the API that abstracts the resource request. Because in case of the bandwidth and the minimum bandwidth request, we have port that abstracts the network pipe we have, and that has some additional meaning that okay, I need a minimum bandwidth rule on that. And the end user just sees that I want to have a minimum bandwidth rule. And Nova will see a resource request based on that rule the end user set. And there is this way to abstract it for the end user. It's not a resource classes and traits that the end user talks about. It talks about some more abstract thing, a minimum bandwidth rule. And that seems more user friendly.
Well, but you know, for example, for GPUs, you will imagine a huge number of traits given by the flavor about I want that specific crazy feeling, I want that other specific crazy feeling. And you don't have any kind of way to say, and I'm particularly not super happy with that, to say, because that would be then more specific.
Wait, no, the top-level thing you do, because the top-level thing, I stopped putting the GPU request into the main flavor. It is its own top-level thing, which is embedded in X, and on the boot, let's say,
don't want to boot NVIDIA or something. I mean, what I want is to have some way to say, I want to have that number of heads, I want to have that fundamental size, I want to have this and this.
I feel like if we add the top level thing, we're gonna end up proxying every hardware detail of everything downstream of us. So all that network stuff that you just said, you know, is kind of implied here, and you know, potentially FPGA things. Nova ends up having to store all of that stuff so that when you ask for one of those things, it knows what to request and from who, right? And they're not all going to be super generic. Some of them are going to be very nuance specific, right?
Right now in the bandit case, what Nova knows is the port ID. And Nova goes to neutral and asks, okay, in this port, what is the resource request for this port?
Yeah.
And that could be generic in the sense if Cyborg will be the device handler, and there will be a device ID in Cyborg, Nova would get that in the boot and go to Cyborg and ask for what is the resource request of this device.
Right, why would Cyborg have this device profile?
I would think it would.
It should. And how do you know which of these things you're going to go ask about a thing, about a resource? So is there a registry of resource classes to handlers?
Well, there's 3 right now, so it's not a huge problem.
Well, is the support, go to Neutron. Is this a volume, go to Cinder.
Else.
Is this anything else, go to Cyborg.
Right?
No, I mean, that's
It's just-
essentially what would be argued in.
It's just not an interact
That
that
problem,
problem.
that's an answer, okay.
Shouldn't, I mean,
It's not, I don't think it's a state of the law.
we have a registry for everything else.
Yeah.
Why do I have a device?
And what, I mean, why is it
Well,
not?
because, I'm just saying, because if it's a port, but there's 5, 7 different kinds of ports or whatever, which is finding a list of those, and we happen to know that those are ports. If it's a volume, yes, right, it's just, there's like, what, 2 different kinds of volumes or something, right? If it's a device, we're talking about having these resource classes that are, could be, this could be an infinite space.
Right.
So as long as that's else, great, but when something else comes along, if it's also.
So that's why, instead of, why not just pass this dash device profile ID or whatever from, and that's the trigger that says, oh, it's device profile.
The flag
go ask
is-
Cyborg what the heck this is.
The flag is what indicates which handler.
That's
That's fine by me, that makes perfect sense.
This flag, obviously, in CLI terms.
Yeah.
would be a-
But Jay, that's not what I'm
The key.
talking about.
That's what I was talking about.
Just to be totally clear, the source class for Azure type. So your PD is the single resource class, GB is the single resource class.
Yeah, I mean,
That's what they already
that-
said.
yes, right? Sean's talking about having potentially customizable resource classes specific to, a certain kind of card if you wanted to.
Well, I don't want to vendor neutrality in traits, but there needs to go somewhere to give some resource class, so NVIDIA, whatever, is a different resource class, and AMD, whatever.
I heard something wrong about so.
Or you could do what you're suggesting, which is custom underscore accelerated GPU.
Quotas are per resource class. You don't
Yes.
necessarily want quota per NVIDIA GPU or for AMD GPUs.
Maybe that's a limitation of quotas right now. But I think, yeah, the metadata thing on what vendor of this it is a separate thing from the right. So.
Also, one VM can have multiple profiles,
Just because that device profile for any, like you want 2 GPUs, you just put it there twice. With 2 different
Just so you're clear, you're talking about device profile as a new top-level Nova object, right? Sure.
Oh, I'm not.
Okay, that's what they're talking about, and that's what you agreed with.
No,
Yeah.
I would, no.
That's what they think you agreed with.
Well, just like a neutron port is not a top-level Nova object.
It's a UUID.
It's just an identifier that triggers Nova to say, oh,
And by
hi,
virtue
neutron, what the heck is this?
of having said port, you code a neutron.
Right.
And
And I'm
by virtue of
saying,
saying
if you see
device,
device profile
And you go to
in the
Cyborg.
request, then you just say, oh,
So I,
Cyborg, what the heck is this?
so I prefer that to volume neutron else. I prefer that approach because otherwise custom resource classes are worthless.
I'm okay with this as well.
The user will provide the
Where did
device.
they get it from?
They went to Cyborg.
Query Cyborg.
They
device.
asked Cyborg for the profile ID and then they passed the profile ID to attach
Yeah, right.
something.
I'm okay with that as well, so long as I can do that.
We validated with
Very
this
similar to
again,
how we
and
do
then-
with Cinder and. So that we don't have to store what device profile is, we just ask. for it.
Yeah.
Yeah.
As long as we have an
And then-
agreement between Cyborg and.
That aligns with all the specs that.
Okay. So, Sean's wrong, we can just acknowledge.
Yeah,
Well, it's putting that on Cyborg, that thing.
Yes.
But the thing with, the problem with that then is that, the thing that doesn't address is that everyone has to go to Cyborg always to do everything ahead of time,
No, just to query what device profile they want.
right?
Okay, that's not like going and creating a device ahead of time.
It's similar to creating neutron port though, right?
No, it's
Yeah,
not. It's just selecting what type of device profile you want to attach.
Well, it's similar to
It's like-
Neutron going
yeah.
to get the network that you need to attach.
I guess.
But the device is also associated with network, right? So how?
Different
Yeah,
cameras.
but
Yeah, but that is part of the proposal, right? If somebody want to list all the networks that are on
Completely
the.
agree. So I'm gonna have to go talk to Neutron and Cyborg.
Cyborg.
And we're gonna have to.
yeah, so in order to boot a volume-backed networked instance with a GPU,
Correct.
you had to go talk to Keystone and then talk to Cinder, Neutron, Cyborg, collect all of these device IDs, and then go.
Which is exactly what the NFM or NAM system is gonna be doing anyway.
But people are constantly complaining about that workflow for us, right?
We're not an orchestrator. Oh, we are. We're the orchestrator. Oh, Matt, you're out there. I don't know. I mean, the device profile is like, that's the menu of things, right?
If-
So you go ask something for the menu of things, you select from the menu, and then you ask the waiter, I'd like this. The waiter is Nova, the menu is Cyborg.
I would be happy if we have that device profile on plan. I don't care if it's just a UID account from Cyborg, but so long as we can decouple these are the devices I want from the rest of the VM specific stuff. I think that's
it seems like the right approach is to do this the same way that we do networks and volumes, and then if we want to make all of those things go away into more of an orchestrating type thing later on, we should do it for all of them and not just start off with one.
It has nothing to do with orchestration at all.
Okay, forget I said orchestration. If we want to make it so that you don't have to go talk to the other service, so you can just talk to Nova, and we should do that for all of the things. Otherwise, I think we'd better have consistent experience across the different ways of doing things rather than have a new way of doing this new thing. And do a different way of doing it.
Whatever.
I'd repeat that I'd put down to sleep.
So the decision is for Cyborg to have a REST endpoint that will be able to list these device profiles. It will essentially be the resources that are requested, required trades, forbidden trades, whatever. And then the user will pass a device profile ID, which is an
This is like the exact same Claire idea, rate config stuff we talked about in Dublin, right?
Yes. Only they would be storing that in Glance or something else.
Cyborg can list isolators and devices with remote traits and such. But with one level above it, they should package to in some form of a single profile says this reference, these traits.
Akin to a flavor.
It's a request. It's not what the accelerator provides. That's different. You're already sending that inventory information placement.
Right.
But if this is to mask the ugly details of the request, right? The custom resource classes, and these traits and those traits or whatever, mask that in a nice little NVIDIA, right? Just like a tag or whatever. So the user can say device profile UUID equals whatever, and that just refers to a set of traits that correspond to this NVIDIA GPU.
They will have a flavor explosion.
Or possibly.
They will have the thing that we don't want, the flavor explosion, they will have. Because they're going to have a device profile for every CUDA version and every NVIDIA binary API version and every, all of that stuff, right?
Wait, so we're not talking about equivalent to like port create followed by port attach. We're talking about some.
Well, that's the thing. If you're going to go to Cyborg and pre-provision, see, a port is something that you have created that you now own that has some attributes. That's different than the device profile thing that they're talking about.
Well, no. So Cyborg has a thing called demand, which is pretty equivalent to the port. You pre-create this thing and it carves, like if it was a VF of some kind, it would carve it off and assign its POS and whatever. Like create all.
That's different than the menu thing that Jay is talking about, which is like a list of
which is a
flavors.
which is an actual profile of thing that doesn't exist yet.
Correct.
You go and ask for a profile, and then it would create the thing.
Right. So with a big-ish cloud with a bunch of composable hardware, that will be a list of 10 billion flavors.
Right. Yes. Well, which way do we do that for ports right now?
No, it doesn't work that way.
But
For ports, you
one thing that the end user can do
right, and then you attach the port. Right. So I'm saying, like, let's do the same. Create van, attach van.
Yeah.
The band is on a specific thing, though, right?
Yeah.
So
So
that's
that.
not what.
But you can't create that until you know where you're going to be. Right?
Unless you do what we do with the
We're talking
default
about
with the late binding, where we have the.
But we want it to be not different than the way it works with scheduling when you aren't somewhere yet, right?
Right.
Do something at the flavor level, right? So if I understand what is syntactic sugar.
Yes.
If you already have a bunch of things, you want to say 10 different things of flavors, so one thing instead.
Yes.
Do a transmission internally.
Yes.
Okay.
Not quite.
Not quite.
That means that the end user can never express that I want these particular things. The operator has to pre-create flavors and get flavor exploded. So if you want to get rid of the flavor exploded thing, it needs to be, I can list the profiles separately from the main
Well,
flavor.
Eric's saying there's no,
components of the
it's
profile.
not like that. Eric's saying that in Cyborg you create some like thing, I can't understand the name you're saying it's named, but you create this thing, and then if you know its ID, then you can just say.
Right. Just like we don't currently allow
I just create
a user to say, boot me this flavor, but change the memory to this exact.
No,
we don't
but
allow that.
that's what this van is, right?
Yeah, so there's two different stories for creating with the device versus hot attach it afterwards. Hot attach it afterwards, I don't think anybody has a problem with. I already know where I'm at, go create the van and attach the van, right? That's for hot attach, that's okay.
Yeah, I mean, if that's what the ban is.
But that is equivalent to a port binding.
Equivalent to a port UUID, right?
No, it's not, because the port UUID does not have a host associated with it at the start. The van is what you get after a port binding, so that the host is this, and it's all the backend specific information.
So now,
If you already have it now, we said it'll take the computer, why are you attaching it?
well, you have to attach to the VM still, right? It's
Yeah.
right.
So I can't do a van create if you have the van create as a host. I could do a logical device create, which is all the profile information, pass that in.
So the same primitives apply to create my VM with the thing already attached, because the resources are in your flavor associated with the device that you want to attach.
That's the thing, we have this profile thing, the resources are no longer listed in flavor, they're listed in that profile.
Unless we make it different for scheduling and attach,
Yeah,
which is, that doesn't, I don't.
Can we like create the profiles specific to the device and then add the profiles to the flavor and then boot it? So
But that's an unbound thing, which is not what a van is, right?
A van, yeah, a van is equivalent to the port binding, it's after.
It's a virtual van that doesn't exist yet.
What does van stand for?
Virtual Acceleration Nexus, don't ask what Nexus is. We can take that term, but that's the components and specs, so, yeah.
Okay, I think we can. I think. Hi, Sander. Let's table this to the afternoon since Liu Li still have a topic.
Oh, okay.
Can we go to the
Have you concluded this one? It's not concluded yet.
We can continue in the afternoon. I think yeah. So the last topic for the morning is from Lilio about the domain-specific architecture support. So I've put the slide link on the Etherpad. You can either click on the slide or click into the Zoom meeting. But
is there a screen that you could a monitor or something?
We don't have a monitor, so yeah, right.
I'll share my screen then.
Yeah, I can give you.
And call out the slide numbers, please.
Okay. Well, it's only like 7 or 8 pages. Should be quick. I couldn't share my screen.
It just make you the host, Uncle Lee. Can you share it now?
Okay. Desktop. All right. How can I present this? Okay. All right. So let's skip all the detail of implementation on the crap. I mean, right now I just want to talk about different views of seeing what we know as accelerators. Because nowadays, because I'm a hardware guy, and nowadays in the hardware world, in the computer architecture world, people start talking about domain-specific architecture hardwares, and this is really the very hot topic right now. And then I think that Cyborg can help in this space. Just an introduction of what this is, and I hope I can kind of introduce a new way of looking at accelerators. So what is domain-specific architecture hardware? It's basically this type of hardware that's designed to do just a small set of work, but does them really, really well. Here's a graph of Moore's law. Like Moore's law is already being, we claim is already dead, right? It's no longer grow in the scale it's supposed to be. And one of the interesting fact that if you look at the blue line, that's the red line is the Moore's law plot, and the blue line is number of papers related to machine learning within the last few years. As you can see, the number of paper already outrun the Moore's law. So that tells us what? That tells us there is a lot of data to be processed, and we have, if we still stick to the what we have for the computer like architecture, we might not be able to handle all of this data. That's why people start looking at the domain-specific stuff. So what are they? Like the domain-specific architectures or hardware can achieve higher efficiency by tailoring architectures to characteristics of a specific domain, not one application, but a domain of applications. And so it's more effective parallelism for a specific domain, more effective use of memory bandwidth, and eliminate unneeded accuracy as well. And it also, in order to use of these domain-specific architectures, we need domain-specific programming languages like OpenGL or TensorFlow. They all consider as domain-specific languages. So these are some typical domain-specific architectures. We probably talk about this in morning a lot, but they all fall into the DSAs from Harvard people's mind. So like MPUs, like TPU or MPUs, or GPUs, or SmartNIC or FPGA, they all domain-specific architectures. And so what's still missing in the picture? If you could look at this picture here, what's the slide number? Number 6, right? This is the full stack of software hardware for the entire, for the model application. On a very high level, we have the applications written in CNN or RNN or image processing models. And we have TensorFlow or some other, or Caffe or some other application frameworks to handle these applications. And before we go into actually the hardwares like GPU, FPGA, or something else, or the DSAs, we need a tool chain and resource management and scheduling to be able to map these operations into the hardware. And that's where I think Cyborg can help. Cyborg can provide a future-proof solution for resource pool management and remote accelerators, and it's the last mile to deliver the DSAs to users, which in this case is the upper-level application framework as well as the applications. So how to achieve this? Cyborg can just live. It can totally live on its own to work with other frameworks like Kubernetes, OpenStack, or something else. And then it provides API to help resource scheduling, allocation, binding to places, to place the DSA at the right place at the right time. If you look at the modern programming model, right, inputs are massive data. They flows in like it flows in like water, right? So Cyborg is the one that actually helps to guide the water to flow into the right direction. I think if you look at this way, I think I believe this is a new way looking at what Cyborg can do for those accelerators. Yeah, this is just that's it. That's all my slide. Just from a power guy's perspective, so what I believe the future for Cyborg should be.
To me, that sounds like a very different project than what Cyborg is, because it's inferring that it's looking at the application layer rather than the infrastructure layer, and determining what accelerators are required for that specific application.
Rather
I just it's really like I couldn't hear it very clearly.
Wait a minute.
Sorry, guys.
You're almost face to face.
I miss you guys. Damn, I miss you guys.
Okay, so my comment was that sounds like a different project scope than Cyborg's current scope, because you're moving the scope of Cyborg to be looking at the application's workload and trying to determine what accelerators will be the best thing to optimize that workload, rather than having it manage the devices on the platform. You're moving more into a kind of a PaaS layer rather than IaaS.
Yeah, you're right. So from this picture, right? If you look down, Cyborg is totally doing an ice layer thing, right? If you look down there, it's just managing all the stuff underneath it. It's like GPU, FPGA, TPU, right? But if you look up, like when you expose those APIs to upper level, I mean, what Cyborg should help is the upper level frameworks like TensorFlow, or something else. So, because it could be packaged or coupled together with TensorFlow or some other frameworks to look like a PaaS level service, but under the Cyborg is still just providing those APIs for you, for it to interact with them, right?
Sorry, maybe I'm unclear about the change by itself, but are you proposing to have Cyborg managing vendor-specific libraries for managing the resources? Are you proposing to have Cyborg managing the application layer itself?
Not really managing an application layer, because the Cyborg shouldn't. Because if you look at this picture, the picture at slide 7, Cyborg shouldn't be visible to the upper level application at all. It's only visible to, say, application framework. And all they know, they don't even know, like application framework doesn't even need to know what's underneath there, like GPU, FPGA, or anything, right? All they know is like I have a matrix multiply to do, like I have tons of matrix multiply to do, right? I mean, and then it turns to the tool chain to map all those matrix multiplied to individual operations. And then the resource management look at what's available for.
Okay, so just to give you an example where I'm pretty unclear.
Mm-hmm.
Say I'm an application developer. I want to use a specific CUDA library of that specific versioning. So I need to have that specific CUDA library to be installed on my guest. What I need, of course, is to have a GPU-capable device that will be able to use my CUDA application layer, my CUDA library, if you prefer.
Mm-hmm.
So for the moment, Cyborg, if we say that Cyborg is giving you a GPU capability, it leaves the responsibility to the user to install the CUDA library and other stuff. From what I understand, you're probably trying to modify that specific paradigm for having, like, for example, say I'm an application developer and I want a specific CUDA library, then Cyborg will propose me some specific version of that specific library and will manage the provisioning of that specific library and the hardware underneath.
Oh, I mean, this is really down to the implementation details. But what I'm trying to say here is, okay.
This is not implementation details. Sorry, this is. I mean, I'm sorry about that. What I'm pretty clear at the moment with the Cyborg scope is that you don't manage what's within the guest, right? You're just proposing either for example, this is a PCI ID for the moment. So you're proposing a PCI ID, and then it's up to the application developer, or if you prefer, to someone to manage the library and other stuff.
Well, ideally, the application developer shouldn't even care what's
Sure. Okay. So say
all they know is
I'm an operator. I will have a set of images. I will have a set of images that will contain my specific library, able to use that specific accelerator. So I will say, okay, use that specific flavor and use that specific image, and then you'll be able to manage your application. That's okay. Sorry, that shouldn't be the end user. I agree with you, but that's not. I mean, that's currently what you have. What I'm a bit unclear is whether you're asking to have Cyborg also managing the image.
No. Cyborg doesn't care about data itself, right? Cyborg just cares about the unit that processes data. It doesn't care about the data itself, right? The data, who cares about the data is the application, right? Application writes their networks, their program model to process these data, but even the application framework doesn't care about data, right?
Yeah, it's hugely. Because when you're actually writing the application, you're going to model the data in a format that will work with the accelerators they're using. So you're going to transform the data differently basically if you're targeting an FPGA versus a GPU versus executing on a CPU. Because the cache interactions and everything will change. Your cache line length, how you want to actually segment this into multiple threads, all of that is highly hardware specific, and TensorFlow has ways to abstract some of this, so it can delegate the matrix multiplications to GPUs, etc. But that information leaks into the application. Now they have to write to that specific framework. And this particular case, you're suggesting that each of the frameworks would have to be adapted to work with this Cyborg mediation layer to be able to do the translation. So this proposal sounds like something that sits maybe on top of Cyborg or Nova, but it's not actually part of either of those projects.
And there is another aspect of the application is the scaling, right? In this data-intensive applications, you have scaling needs, right? And how do you decide like which host you are going to flash next with the particular FPGA to scale out or scale in, right? So that's another thing I haven't seen addressed yet. So
you're right. I mean, this one in this slide, I didn't really show how Cyborg will be tackled into TensorFlow or something else. What I'm saying is Cyborg can really play a role in this stack as one building block for this entire ecosystem.
Yeah, I think to summarize Lee's proposal is that for domain-specific architectures, unlike CPU, GPU, those things we're familiar with, is that we might need additional information. I think that's the bottom line of Lee's proposal, and maybe worth looking into.
But it sounds like it's a optimization layer that you would want to use to query what's the best set of accelerators that have this particular workload framework they have.
Yeah.
And that sounds like a separate project that just sits to the side that can understand how to solve Cyborg. Or could talk to other things, but it doesn't sound like it's a core part of Cyborg's mission statement.
I agree. So what I'm really want to do here is I want to propose a new way of looking at the accelerators, because originally we traditionally we look at accelerators as just it's just something binded with a host or a CPU, and then you offload some of the CPU work onto the accelerator to hope they will be faster. But in hardware world, things are changing, and then this is probably what we will be going in the future. From computer architecture or from hardware perspective, this is what this will be going in the future. That's why I hope that this can help people at least from the Cyborg project folks, that okay, this should be a new way of looking at accelerators.
I think there's a dichotomy here though between the view you see for how hardware is evolving and the direction that software has been taking, because from the software point of view, we're trying to extract away as much of the detail as possible. And also optimizing the way we represent the data structures with the tablet up. If I'm going for a GPU-based architecture, I will format the data in such a way that it's acceptable for that. And I'm going to FPGA solution, I'll format in a slightly different way. Because I think there's a conflict here between where you see the hardware going and where you expect the stuff to. I may be wrong though. But
yeah, I think that's going to be like a long time ongoing battle, or well, not battle, but yeah, trade-off that people will. Yeah, so the domain-specific architecture was championed by the RISC-V community. Basically, means in the age of artificial intelligence, you have to design your own specific chip to run your. That's the message of.
You might, but then you also have these general purpose stuff, so the APU that you're suggesting coming to market. And I think what is also going to be likely and frameworks but optimized by the hardware vendors for those things, which will raise the value of you making your own chip design and targeting a broad audience, right? For these generic frameworks. So if you're an application developer just writing a TensorFlow app, they really don't want to know what the thing is. And I think it could be conflating two roles as well. You have the application developer who develops the application. Then you have the operator, the person who's deploying it. And they're the ones that need to understand how to optimize the resources that are provided to an application, not the end application user or the writer.
Yeah.
Right.
Okay.
All right.
That's the morning session, and see you guys 2 p.m. for the Nova Cyborg interaction.
Okay, so that's
And
so that's 2 hours from now, right?
yeah, an hour and a half.
Okay, it's 2 p.m. here already, so I'll be 4 for me. Okay.
Okay.
All right.
All right.
Talk to you guys later.
Yeah, talk to you later.